Okay, 8 o'clock now, so we'll get started. Thank you everybody for joining us. It's nice to be back in person after a couple of years of doing this virtually. We have a little bit of change in the schedule. Our Army Corps representative will be coming a little late, so just a little bit of shifting, but he'll be speaking during the afternoon slot. So I'm Patrick. I'm with the Kane DuPage Soil Water Conservation District. If you were here the last time we did a seminar here, or you watched us virtually over the past couple of years, you might recognize me. Today, I'm going to give a presentation about in-stream work that I felt would have been very valuable had I started here. So, give a little bit of what I'm looking for when I conduct a in-stream work review. And, so let's get started with why I have the in-stream work plan. Well, for starters, we have that it's one of the contingencies with the Army Corps requiring our involvement for certain projects in jurisdictional work, the means and methods in order to perform the work. You submit an additional plan to our office that highlights those proposed means and methods in order to get the work done cleanly and effectively. Even if you don't have a Army Corps permit, but you figure for the sake of good water quality, you put one of these together so that you can work in the dry when you need to and make sure the downstream water quality is in good condition. I put this one in red. It's leave it up to the contractor, because when it comes to, and we were here last year for the Illinois Road Builders Association, and we were talking about how much of the in-stream work plan relies on the designer versus how much relies on the contractor. Now, it was said that you should leave it open, very open to the contractor, give them a lot of flexibility to put something together on their end because they have the expertise they'll be getting in the stream and doing the work, versus the designer where you're already putting the engineering plans together and it's helpful, it's a starting point, but the contractor could always go back and potentially make some revisions on their end to update the plan so that it'll be effective on their estimation. And then we get a lot of applications into our office, so sometimes certain applicants do not know what to put in their proposed plan. So a lot of the times I find myself referring them to the Illinois Urban Manual, and we'll have a presentation on the Illinois Urban Manual and kind of what it relates to in-stream work at a later speaking session today. So versus that designer versus the contractor. When the designer puts it together, it's nice and it's already built in the plan set, and it highlights it, and for the most part calls for all the BMPs that will be used throughout the day. I'll be saying BMPs, that means best management practices, versus the contractor submitting one. So a lot of the times it's just a sketch on top of what's currently in place. You call out the components that are required in the in-stream work plan, and I'll go over those components right here. So general guidance, we saw those couple plans. They started with the engineering plans, or you start with maybe an aerial image. You highlight the important aspects of the plan, the protection measures. You highlight the narrative, what's the sequence of events that's going to take place, identify the stabilization measures, whether those be temporary or permanent throughout the stage of the sequence of construction. You, again, highlight the best management practices. You reference some type of engineering specification to go with them. So a lot of these times, these independent submissions are tied with the pre-approved engineering plans. So a lot of the times, I'm going to ask during that initial review when we're approving the engineering plans if they can include those standard drawings, so those could be options at a later stage. So the general guidance is move the water away from the site. So we have our different methods for stream diversion. whether that be through a bypass pump, moving the water, pumping it past the site. If you have a nice situation where you have a nice straight shot going through the site, perhaps you could use a pipe bypass. That thing will sit there, collect the water, and just let the clean water roll on right past the site. And then if you have a little more extra space, or you have the option to be a little creative, you might put something like a diversion channel where you could redirect the water past the area where you're performing the work. And then obviously we want to move that water away cleanly. So we're going to prioritize the condition of the water as it's gone past the site. Going to compare what the upstream condition is versus what the downstream condition is. Right now it's just a visual assessment. So for that first diversion method, the pump around, we have the components of capturing the water at the intake and then discharging it on the downstream end, make sure it hits a stable outfall on its way. We highlight that bypass system right here. And then we also have our upstream and downstream dam in place and proposed. Now that work area between there, let's see the clicker. Okay. This area, we want to identify how that water that accumulates in that area, the most disturbed part, how is that going to be treated throughout the life of the project. So that's what this kind of goes into. We have this in-stream work area. It's captured. It's taken to a series of measures to potentially filter that water more. So we want to filter at that intake, but we want to filter at in this instance, we want to filter at the bag, and then it has a long train of treatment, and Jonathan's going to talk a little bit about how you could utilize some of these type of methods in your treatment train, like polymer. So just looking at this engineering plan, this proposed in-stream work plan, we have our upstream and downstream cofferdam, we have our bypass pump, and it's pumping to a bag. So we got our pump, got our bag. The problem is, for this one, this is a problem I see when we're doing these a lot, is this is water that's just being bypassed. So this water doesn't need to be filtered by a bag. This could go just right past the site. But what I want to see when I'm reviewing a plan is what's going to be done with the water that accumulates in this in-stream work area, because this is the water that's going to likely need to be filtered as opposed to the bypass water. So I'd want to see a location for that dewatering bag, and in addition to this, move it down a little so when it's leaving the bag, it's not just going right back into the in-stream work area. So we want to, again, move water past the site. So as that flows, well, a little recommended revision, just keep that going, hit it to a stable outfall, make its way back into the creek, matches the upstream condition, then it's fine. And then that second one, you pump away, and you have a stable dewatering operation on some type of pad that meets the Illinois Urban Manual standard, and then it could go right into the stream. So just identifying another plan here. So what we're looking at is the proposed in-stream work area, and then we have two sumps feeding into that sediment filter bag. Well, my note to the applicant is that this one, again, doesn't need to be filtered at any point in time. If this is upstream of that upstream cofferdam, then that can just go straight around the work site, while this one will still need to remain filtered. And then we can see all the different BMPs that are proposed on this drawing, so it does a good job of reflecting, and the different colors help kind of read the plan a little easier. So these plans come in a variety of different formats. We have a nice colored sketch right here. So anything will really do. It's up to you as the designer or the contractor, whatever you see fit. This is another instance where I would come back during my review period, and I would request that, can we please identify the area where this is going to be treated. So we have our bypass, but I want to see where this is going, and I want to see specifically where the bag is going. So I'm going to ask them to maybe take a photo. That's why I like to see an aerial image, because you could potentially see what the existing ground cover is. So you might just put a bag somewhere on the engineering plans and call it a day, but we kind of hash this out at the pre-construction meeting, but before that I like to suggest putting a location that you know will be nice and stable, and it will provide a stable pathway of conveyance for that water that was just filtered to make its way back into the stream, so that it meets the recommendations of the permit. This is a good example. So we have our pump around going all the way past the cofferdam, and then we have the intake right here going past it and being filtered. Identify a nice location with a consistent slope that could feed right back into here. Now, this will capture some of the water, but the pump that's going to be right here is likely going to be capturing more of the water because it's going to move down slope. So I want that to be identified too, potentially two sump pits. So this is what I'm talking about when you're out on the site and you have a designated location for it. If you reference the Illinois Urban Manual standard, it shouldn't be in the water, so it should be in a nice, stable location outside of the waterway. So this, if the bag is failing, there's no additional filtration mechanism before it makes its way back into the stream. And I know once we're in DuPage County and we're in some of these small corridor projects that you're really limited on space, but I'm going to emphasize that if there's any way that you could sync up with an adjacent landowner or something, so you have additional space to give way to that dewatering pad, that'd be really valuable. And then when you have a configuration like that, and you're in these really close quarters, you're having to make these proposed these correction items that don't really meet the technical standard, and then eventually just the big rains come by and it just takes the site away with it. So I'm always finding myself sending people to this guideline sheet in the Illinois Urban Manual Dewatering Standard, so that they could see that, okay, here's some of the criteria. It should be on a flat, stable surface, or if it needs to be on a slope, there's just general guidance that you could use as a starting point, and then as you're out in the field, you could reference it as well. Okay, then another stream bypass is the pipe mechanism. So, like I said, taking that water that's on the upstream end, just moving it right to the downstream end, if your in-stream work area is suitable for that. Here we have a combination of the two of them. So we have whatever water can make its way into that pipe, that could just go right past. You save yourself some energy by less running of the pumps. But then we also have a call out for a pump around as well. So we have two mechanisms called out on here. I like that because, as we get lower and the elevation of that water that's feeding into the pump keeps getting lower, and that sump could come in, and you could be actively addressing the incoming water as you go. And then this one on the downstream end of that dewatering or that in-stream work configuration, that's going to capture the water, and it's going to filter it, make its way back into the creek. So how this kind of looks out in the field is we have a nice stable location where we could direct the water into the pipe, and then the pipe is strong enough to hold the water, and it's elevated in this instance, so you try not to bump into it, and you have it try to be in a convenient location. No, it's not always easy to have that, but we have our sump pit right here that's going to capture a lot of the water that accumulates in here. So imagine every time it rains, and if you have a downstream cofferdam in place, there's going to be a buildup of water. That's always going to be one consideration for an effective in-stream work plan. And then the outfall of that pipe is going to have a nice stable location to hit the ground, hit the downstream bed easily and not disrupt that. One thing I would like to see, because we just showed this area right here, is the in-stream work area. And then we have this row of sandbags that's going to capture that excess water that gets out that isn't captured by the pumps. So maybe increase that elevation so that we have a secondary confinement-like mechanism in place. But it's an effective practice for moving water right past your site. So if you're fortunate enough to have a straight shot like that, I encourage using the pipe as an effective method, and then again, putting the two bypass methods, both the pipe and the pumping, on the plan as options. And then we have the diversion bypass. So this is going to create a new stable pathway to make the water move around the site. So it's going to be diverted, and then one area you're working and it's hypothetically staying dry the whole time. One channel is accepting all the water, the clean water that's coming from the upstream side, and just gracefully pushing it right past the site. Some things I would like on just this drawing, but just for the sake of showing the diversion, they didn't include it, but you'll see that you'd also want to have some type of soil erosion protection measures right along here, so that the water that's coming by here isn't the disturbed slopes that are contributing to that aren't letting sediment-laden water make its way into that diversion channel. So it starts with redirecting the water, so intercepting that flow and making its way. So we could see that this area is actively being worked where the stream naturally would have wanted to go. And then we have our area that's acting as a bypass around the site, and it's going to go a long way out until the outfall. Calling it out on the engineering plans, the means and methods, we have a proposed diversion channel that's going to bypass that oxbow, and it's going to just collect the water, and it's going to go straight there temporarily, and then they could work in this area in the dry, hypothetically, and then all this area that you're working on, you'd hope you'd have some type of downstream mechanism in place to capture that and filter it if need be. Another instance of proposed in-stream work plan where we have a diversion channel making its way past the site. We have identified locations for a dewatering pump on the downstream end. We got our 2 cofferdams, and then that's what we're looking for right there. Another instance of just a call out of the diversion channel and different practices that you could include in the diversion channel. So you could include your, in this instance, they have ditch checks in there. And then again, we have our diversion channel that we would want to put some type of perimeter control in between the soil stockpiles and this, because this is going to go every time it rains, it's going to drop and hit that splash and then make its way directly off-site. So if we can move those stockpiles, that would be nice. If you can't, try to figure out some type of way to intercept that surface water runoff before it makes its way into the channel. And then the Illinois Urban Manual has a bunch of different options for a cofferdam. A lot of the times I like to request to put as many of those as seem based off of the hydrology, what's feasible out there, and just give the contractor some options to work off of. A lot of the times we might get a means and methods into the office and people will just use this as a starting point, just this standard drawing, and kind of make it as close as their site conditions as possible. And that's perfectly fine too. So a couple different options, and if you just reference the Illinois Urban Manual, if you're at a stage where you're thinking about how are we going to perform this work in the dry, again, I'd recommend going to the Illinois Urban Manual and seeing what's on there, what drawings are on there, and if you follow that, for the most part, that's what the code is, or sorry, that's what the permit's asking for. So a well-placed steel sheet cofferdam that's going to allow water to divert past the site, and it's going to, that clean water is just moving right past it. The only area that they have to worry about pumping the water out and treating it is what accumulates right here. We'd like a little more protection measures going along that diversion channel, so that's something to think about when you're putting together this in-stream work plan. And it's convenient when you have a bunch of space and you have a little bit of leverage for how you're moving water across the site. And then that location of the dewatering bag, is it contributing back into the in-stream work area? Well, that's not good. I know the field conditions are going to be a little different and things will change, but I'll take these plans literally where you place them and think about, well, the water leaves that bag, where is it going back into? Well, if it's going back into the in-stream work area, we just have to keep refiltering it. It's not ideal. So you want to have it downstream, and again, that stable pathway of conveyance back into the river right here. And then highlighting the sequence on the plans. So this is the work that's going to be taking place on the east end. This is the work that's going to be taking place on the right end. They're pretty much mirror images of each other, but it's worth calling out because you're identifying two different dewatering pad locations in this instance, so that's worth it. Then we have our sump pit. How's that intake going to help that filtration process before it makes its way into the dewatering bags? Can we filter it out a little more? And what are some best practices to do at that intake so that we can reduce the amount of times we're having to replace the bags on site? And with each of those standard drawings, so we call out the sub-pit plan. Each BMP you propose on the means and methods, I'd expect to see a drawing specification for each of them, preferably. We don't have an Illinois Urban Manual standard drawing, but that would be something, if you have some type of manufacturer specification that you could include in the plans, that'd be great as well. Here's another plan where we have a few BMPs called out for. We have our ditch checks, we have our stream crossings, our cofferdams. So we'd expect that if the initially approved engineering plans don't already have them, that you include those in the means and methods and in the plan set that you propose in the means and methods. So this is a good plan because it calls out a bunch of different practices that would need to be taken into consideration and different precautions to think about throughout the life of the project. And we have our sequence of events. So the contractor a lot of the time will include step by step what's it going to take in order to execute this process. And then we review those plans, see about, again, those stabilization precautions that you talk about throughout that sequence of events. and how it relates to that schematic where you're laying out the actual in-stream work area and the plan. Again, with the sequencing, so you call out each of the phases along the proposed development, and if you need to break it up into sections, just highlight that on the engineering plans, step by step. Again, sequencing, so this is part 1, part 2, part 3, part 4, and you include all of that in the means and methods that you submit to the office. And then you put your notes on the plans as well, things that you've identified in the field in previous years or previous projects that you've noticed that are problems that could be kind of highlights to the people that are actually doing the work to consider, when the next rain event comes, and things like keep backup best management practices on site. Keep your backup dewatering bags if you need them. Identify a primary location for dewatering. Identify a secondary location if need be. Just evaluate each time, evaluate the amount of water that's contributing to the in-stream work area and see if there's a way to reduce that total amount of watershed area that's contributing to the amount of disturbed ground in that little watershed. That will go a long way. Lots of notes to include. So the summary is just have a schematic, a sequence of events, something you could turn to that actually reflects the plan as much as possible. And these are dynamic plans. You put something together, things change out in the field, just like you would with your SWIP. We'd like to really see if you reflected the revisions on the plan as you go throughout the project. And when you're drafting these plans, feel free to reach out to our office, and we're more than willing to help you put this together. So never hesitate to reach out to our office. We take pride in the fact that we answered the phone call when you call us. And then those dewatering pads, those change throughout the project. So make sure you're using a good one and you're identifying that. That's my contact information. Does anybody have any questions? No? Okay. Okay. Next, we will go to Mark Bremstead, who is our soil scientist, who is going to talk about the important characteristics of soils that you'll find out in the construction site. So, which one? Forward pointer.
Thanks, Patrick. Hey, good morning. Everybody get your coffee and something to eat out there, I hope, right? Too early to be sleeping, so that coffee will keep you going. Patrick talked about using sump pits for dewatering. So it's not only surface water that you're taking care of, but you're also going to be drawing from the water table, and that water is moving through the soil. Well, I'm a soil scientist. I work with Kane, DuPage Soil and Water Conservation District. And so I'm going to talk to you a little bit about the properties that are in the soil that affect that flow of water, both in natural sites and in construction sites. So this is, when I was in school, this is the definition we had about soil. And it applies to the natural conditions. It's a natural body. It's got certain characteristics. It's got a lot of things in it. And it's predictable, it's organized, we can interpret it, it's got a lot of layering, sequencing. We know what's there when we identify soil properties. We can determine how things are going to work, how water's going to move between each of those layers. Well, when we look at soil as a material, and we take that natural soil, about half of that is actually solid material, ground up rocks mostly, a little bit of organic matter, and the other half is just space, pore space, kind of like a sponge. You have a sponge, it's solid, you can hold it in your hand, but it's really full of holes, and that's what soil is too. And the holes vary between being tiny little holes and being large, like earthworm, night crawler holes through the soil. So there's a lot of diversity in a natural soil, and that the pore space, depending upon the time of day and if it's raining or not, that fluctuates between air and water, and so it's not always filled with water, it's not always filled with air, so it's a fluctuating space. So 50% of the soil is pore space in natural conditions. So a microscopic slice of soil, all those dark areas are pore spaces in there. So about, again, 50% of the soil is pore spaces in a natural condition. And so the properties that really affect that pore space, and pores, we want to get the water to flow, it's got to go through pore spaces. It doesn't flow through the mineral matter, it goes through the spaces. So there's 4 things here I'm going to talk about, and in particular just one of them. But soil texture, soil structure, the organic matter, and the biology in the soil all help with that pore space. Let's talk about texture, and that's what we're going to be focusing on mostly. Textures, we're talking about 3 particle sizes here, sand, silt, and clay, and we use names like silt loam, clay loam. That's the texture, or how the soil feels. That's the relative proportion of those particle sizes. So texture is one of the key things that affect the pore space. In a natural soil, we also have structure. The top soil usually has this cottage cheese-like granular structure. You sometimes get in forested areas, you get this little flat platey structure. You can see the little flatness of the plates over here, the structure. In the subsoil, it gets more chunky and blocky, and then sometimes in the lower part of the subsoil, you get these long prisms like that. So soil's got shapes, and it's naturally occurring, and where those shapes come together, that's also cracks and fractures here, and pore space for the water to flow through. Again, soil biology, root channels, wormholes, all sorts of critters are in the soil. They make these holes too, and that helps the water flow through. The larger the hole, of course, the faster the water goes. And so they're important in keeping that open, as well as organic matter. Organic matter really is spongy, light, fluffy stuff that really absorbs and holds water, but also lets water flow through it too. But we don't always work with natural soils, especially on construction sites. Soils have been transported, they're dumped, they're moved, they're graded, they're scraped, they're smashed, and it changes what we just talked about. So what we had is those nice natural layers, fluffy soil, that nice cottage cheese stuff on the surface layer. We get something like this, and this is a good picture of here. Here's a slice of soil. They actually put some of the topsoil back here, but it's so dense and compacted. It's hard, it's blocky, it's sharp-edged. If there is a crack, that's where the roots would go through, but a lot of that is barren of any biological activity, very little biological activity. The pore spaces that we have are no longer those big earthworm holes through there. Everything is tiny and smashed, and it's all been manipulated. Not ideal for moving water through. So this is an example of what happens here. So, and again, in this, first of all, I have to apologize. I made my presentation on a Mac, so it doesn't always translate to Windows computer here. So 50% of this is solid. There's, in the natural state, 50% air and water. Smashed a little bit, you get this 25% pore space. You get this, so you can see air and water doesn't go through as well when you get that, you lose that pore space. Not only do you lose the total pore space, but you also lose the diversity of pores. So you have, in the original condition, you have a dominance of these large pores and a lot of diversity of pore space, which allows the water to go through easily. But when you have this manipulated soils, all the pores now, almost all the pores are very small and tiny. Again, pore space affects water movement. So in a natural site, with this pore diversity, a lot of different pores, increased infiltration, we have reduced erosion, there's less runoff and flooding. But in manipulated environments, we have decreased infiltration, we have accelerated erosion, and we have increased runoff and flooding. So we all know that. It's common sense, but it's the pore space that makes the difference here. So back to the texture. Texture is one of the things that is not impacted, it's not affected by manipulation and compaction. Doesn't matter how much you smash it, you haven't changed how much sand, silt, and clay is in there. We have different ways to describe the texture, and it has to do with the size of the particles. So if you read sand across the bottom, clay across this side, and silt down this side, you can come to the terminology that we use to describe soil texture. You've probably seen soil survey reports. You've probably felt it yourself. So if we take about 33% of all these three texture particle sizes together, we end up here in the middle in what's called a clay loam. Clay loam's about an equal combination of sand, silt, and clay. Most of the soils that we have, at least the upper couple feet of the soils that we have in our area are going to be in this zone right here, and a majority right in this area. So we're looking at clay contents, generally 25 to 40% clay content, sand 5 to 30% at the most. Unless you get, and I'm talking right now, I'll show you a picture here in a little bit of in Kane County. DuPage is a little more coarser soils, but so we have soil texture. This is the USDA textural triangle, which is what I've grown up using basically, but there are other ways to describe soil texture. Down here there's one called Unified. This is the engineers. You can use the Unified texture class. They don't split out silt and clay like USDA does. And this is the American Association of State Highway and Transportation Officials. They have a similar system. So again, ways to describe that relative percent of sand, silt, and clay that's in the soil. So we're going back to this. Sand, it's big. It's a big particle. Let's think like a beach ball. Silt, think more like a ping pong ball in comparison, and clay like the point of a needle. So a really big difference in particle size in those. And to think about it even more, we can actually see individual sand grains. You go to the beach, you can pick up an individual sand grain, visible to the naked eye. Silt particles are much smaller. Sand grains are mostly quartz, feldspar, some other minerals, resistant to weathering. The silt particles, you can only see an individual silt particle using a scanning electron microscope, so they're much more smaller. You can't see that on your hands. And they're still rounded. They're basically ground up sand, ground up minerals like quartz, feldspars, that sort of thing that are resistant to weathering. Again, sand is gritty to the field, gritty to the touch. Even though they're rounded, they're still sharper edged. Silt has been rounded even more, and it's kind of powdery feeling. If you've felt like baby powder, that's how silt would feel. It's smooth feeling, much smaller particles, but again, it's just a ground up rock like sand is. But clay is different. Clay particles are flat instead of spherical or rounded. They're flat shaped, and it's because clay is not just a ground up rock. Clay is built on a molecular scale of what's called a tetrahedron and an octahedron. And they're usually a layer of tetrahedron and octahedron is called a 1-to-1 clay. And then there are, most of the clays around here, we have a layer of tetrahedron with a layer of an octahedron followed by a layer of tetrahedron underneath. So 2 layers of tetrahedrons to 1 octahedron. So that clay is not just a texture, it's not just a particle size. Particle size of clay is less than 2 millimeters, 0.002 millimeters. It's not just a texture that you feel, it's also a mineral. We have lots of different clay minerals. Vermiculite is the name of a clay mineral. Smectite is the name of a clay mineral. One that if you've tried to seal a pond, bentonite is a clay mineral. And they're all different based upon the makeup, the molecular makeup of these layers and the cations that are in between the layers. So clay minerals also, on the molecular scale, carry an electrical charge. They carry a negative electrical charge, and that lets them bond with the cations in the area. So whatever cation they're bonding with will affect the structure. And why bentonite seals ponds so well is when it gets wet, it absorbs water between the layers of those 2-to-1 clays and swells up and doesn't allow then the water to pass through. So it makes a real tight bond there and shuts off the pore spaces. So sand, silt, and clay have extremely different properties. Again, sand visible to the naked eye, you can see individual grains, you can feel the grittiness. Silt, you can see only with scanning electron microscopes, very smooth and powdery. And clay, very sticky, has a molecular structure, carries an electrical charge, a negative electrical charge, it bonds with cations. This all affects the pore space that allows water to move or not move through the soil. So we look at that and we have sand, silt, and clay there on the top. Now in nature, these are almost never pure sand, pure silt, pure clay. It's usually a mixture or a combination of these things. It may be dominated by sand, it may be dominated by clay, but it's generally a mixture. But we're going to look here at the individual components up there. So WR, that's water retention. So sandy soils have the least water retention and have the fastest drainage because the pores are large, so the water doesn't stay within those pores. Gravity is able to pull the water through the sand relatively easily. Silt, soils that are high in silt have great water holding capacity for plants to use. The silty soils have the most available water for plants to use because the pores are smaller, so gravity isn't always pulling it out of the pore space. You get that capillary action that holds on to the water in the pore space. The pores are small enough so that the gravity doesn't pull it out quickly, it's held there so the plants can use it. It's not held so strongly that the plants can't get it away. But silty soils are also easily compacted and they are easily erodible. So that's a surface of most of the soils that we have around here are soils that are high in silt, like 80% or higher in silt content. And that's what we often are moving around when we're doing construction. The clay, on the other hand, actually has the most porosity. It has the most pore space, although the pores are small. And it's showing those as little round things when, again, it should be the clay particles are actually flat. So clay has slow permeability partly because the pores are flat, or the particles are flat, but also because the pore space is really small. So it takes a lot longer for the water to go through. And the water moves in clay soils less by gravity and most by capillary action. So osmosis basically is pulling the water one way or the other. Clay soils have the lowest permeability, the slowest water movement, but the highest water retention. And it doesn't, it's not as available to plants. It will hold more water than the silt soils do, but it's not available to the plants because, again, it has that electrical charge to it. So it can bond tightly with the water and it keeps the plants from being able to extract it. So again, these are the individual particles, but we have to deal with generally a combination of sand, silt, and clay that's in the soil. So when we look at what we have in this area, these are the soil textures that are the most common. Silt loam is the most common surface texture across the whole state of Illinois. And it ranges from 15 to 27% clay, but it's high in silt, so 50 to 85% silt, and generally low in sand. Around here, generally 5 to 10% sand is what you're going to see in the surface layers. So a very low amount of sand, very high amount of silt, and a little bit of clay. The most common subsurface layer is the silty clay loam. it is, again, 27 to 40% clay, so it's got a higher clay content, definitely. A lot of silt. Silt is dominant in this soil, in this texture as well, and again, lower amounts of sand in there. And clay loam is very similar to silty clay loam, except it just has a little bit more sand in it. So these are the most common soil textures that we have in the area, and in Kane County, it's generally anything that is blue in there is not what I'm talking about. Those are the coarser, gravelly, sandier areas of the county, so along the Fox River and some of the glacial deposits that we have in the county. But you look at the rest of the county, 75, 80% or so of the county is dominated by these high silt, high clay soils. If you go down, if you ever work down, say like in Grundy County or Kendall County, down in that way, you can get clay content between 50 and 80% in some of the subsoils. Will County as well. They have some higher clay content soils. So you're going to get some very high clay soils in those areas where the water is going to move very slowly through those. So when we're looking at dewatering and you're using a sump pit of some sort or another, again, you're not just moving surface water, but you have to move the water through the soil to dewater it. And so some of the issues in dewatering these silty and clay soils, and when we say clay soil, it's generally above 35% clay. When we're talking about dewatering those areas, we have some things to be concerned about. The suspended solids that, again, silty soils are easily erodible, so the silts stay in the suspension in the water. They will settle out, but the clays will stay in the solution much longer. So you have to keep that in mind in doing it. And I heard Patrick talk about the filter bags and that sort of thing. So that's why we have that. Otherwise, we'll be moving that muddy water as well as dewatering the area. So these soils have slow permeability, and the more they've been manipulated, generally the slower the permeability is going to be in removing the water. So it's a very slow process. And so you just have to keep that in mind as you're trying to dewater an area. If you don't have some sandy layers to pull the water through, it's going to be a slow process on dewatering the site. And then in restoration, you want to get that water to move through the soil. So how do we get better porosity in the soils? We go back to those things that I talked about in the beginning. First of all, minimize disturbance. The more disturbed it is, the fewer good pores we're going to have, the less pore diversity we're going to have. So we want to do these things. Minimize disturbance. We want to cover the soil, get that organic matter back into it, get living roots in the soil so that we can get some more pore space going. When you get organic matter in the soil and plants growing in the soil, the biotic community comes back and helps on getting the pore diversity going. Also, by planting a diversity of plants, that really helps too. If you're all planting only fine roots like annual grasses or ryegrass or whatever, you're going to get those fine roots. You're not going to get the pore diversity as if you would use something like alfalfa or something that has a coarser root in it that can break through some of that heavy compaction. So these are long-term issues, and the solutions take a long-term or take a while to actually develop. But sand, silt, and clay, they comprise all the soils that we have, and the higher the clay content, the slower the water's going to move through. The more manipulation that we've had on the soil, the slower the water's going to move through the soil. So again, minimize the disturbance, try to maximize the diversity in the pore space, and that maybe will help in the situation that you're in. So any questions? And I'll hang around for a little while too.
How do you, I guess, fix vacancies on our water table and then groundwater table itself?
Okay, seasonal high water table is a fluctuating water table. As the spring rains, the winter precipitation, spring rains come, again, think of soil like a sponge. So you have a sponge sitting in a pan and you pour water into that pan. the water's going to rise into that sponge, and it'll actually come above the level of the water that's in the pan. So seasonal water table is as the precipitation from the winter and spring come, it fills up the ground with this water and fills in that pore space. In some areas, the ground is shaped this way, concave, so the seasonal water table is more near to the surface than it would be on a convex landscape. The seasonal water table is generally lower. Flat landscape, again, it's the material that, the layers of the material will affect how much water it holds and how close that water table will be. So it's seasonal because as the plants use up the water, as the summer gets hotter and you have more evaporation, that water table will actually decrease. And it's not like the permanent groundwater that you'd put a well into. It's a fluctuating thing, and it's held up generally by denser layers with lower permeability that are below that, usually perch the water table above it, above the actual well water table. So the well could be 150 feet down, but you could have a seasonal water table at 2 feet or 1 foot or above the surface during the spring and early summer. Does that help? That's pretty hard in our area. The seasonal water table in this part of the state is usually, in most of the areas, within a foot of the surface in a lot of the area. So that's where you need things like a sump pump, and you need foundation drains, so you can lower that seasonal water table to keep that wetness away from your foundation and away from your basement. So it would be hard to, there are a few areas where you'd have that seasonal water table low enough that you could put in a foundation, but in most of our area, you're going to be in the seasonal water table. If you dig down to 8 feet, 9 feet, 10 feet, you'll be in the seasonal water table. Again, 1 to 2 feet in a lot of our areas, you can hit seasonal water table. So again, you use things that mitigate that, like foundation drains, the sump pump around your foundation in your basement to do that. Backfill with gravel on the, when they dig the hole and put your foundation, they backfill with gravel, and that allows the water then to get down to that sump pump and those foundation drains. Does that help? Okay. Why, do you have a follow-up question, or is that good?
No, I mean, I think, in terms of our, when we do these projects and we do developments, we get soil report that indicates where the water table is and what the seasonal water table is. And sometimes the project, well, you got to jack up your basement because of this, this well water table.
Right, yeah. If you didn't have sump pumps and foundation drains, you'd have a wet basement. It's the same with if you're not on a sanitary sewer system and you're using a septic system, they have to have ways to lower the water table to keep it out of that septic area, that septic field. Otherwise, if the soil is full of water, it's not going to be able to absorb the sewage effluent from the septic system. Any other questions? Right, right. Yeah, you don't want to build a pond at the top of a hill because you won't have that seasonal water table to keep filling that pond. So water flows downhill. It's the key concept you have to remember. So the lower it is in the landscape, the wetter it's going to be. So that's for home sites or ponds or septic fields. Anything else? All right, I'll be hanging around if you think of a question later. And so, Patrick, okay, Tommy is next.
All right. So my name is Tommy Burdom. I'm a resource analyst with the Kane DuPage Soil and Water Conservation District. Today I'm going to talk a little bit more about IUM standards and then kind of how those apply to our dewatering setups. So what we're going to be looking at, kind of how the Illinois Urban Manual is set up and how we can utilize it for planning, designing, implementing, and maintaining these best management practices. We'll look a little bit at it's going to kind of overlap on what Patrick talked about with the review process, but focusing more on those specific standards and what you might find in that, and the associated specifications that are within the manual. And then we'll just look at a few different associated dewatering practices that are in the IUM, and then just some overall takeaways. So for anyone that's unfamiliar, Illinois Urban Manual is a technical reference. Essentially that's used for anyone that will be here today. So anyone that's involved with building site development, land use planning, natural resource conservation, anything of that like. So from anyone from government officials to engineers, inspectors, developers, contractors, it's meant as a technical resource for everyone within that. In its current iteration, it's meant to be a living resource, so it's currently on a website at illinoisurbanmanual.org. But then there's also a couple of field guides that are working on that you'll be able to kind of see some quick references if you're out in the field doing inspections. Currently, it's funded by a grant for the 604B through the IEPA. We're still waiting to hear the next phase of that, so hopefully we can get that going and be able to keep everything updated and utilized to its best, to its full potential. So the way that the Illinois Urban Manual is kind of broken down is there's 7 main sections that are all going to have pertinent information to different aspects throughout the initial design phases of site planning, development, and practice implementation. So we're going to kind of go over how it's going back and forth between our practice standards. We have construction specifications, material specifications, as well as the standard drawings that are involved with that. So those are all going to be central when you're developing a project. Offering the best protection for the resources that are both on and around specific project sites. So going over some of the specific practices today, but there's obviously a wealth of information that we won't be able to cover in full detail. So I'd recommend taking a look at the website specifically, seeing what the manual offers, and being able to utilize that in designing, planning, and implementing some of these practices. It's also important to refer to this over the course of specific projects, both from the initial planning stage all the way through final site stabilization and post-maintenance, just to kind of see what works and what doesn't and be able to kind of build upon that information. So looking at specifically the practice standards that are within the Illinois Urban Manual, so practice standards are going to be kind of broken down into these main sections. Depending on the practice, it might be a little bit longer. It might be site-specific or practice-specific criteria that you may see differ between that. But essentially, it's going to look over the overall practice definition and its purpose for its use, as well as some of the conditions where it may apply. And then decide any specific criteria and conditions to think about while you're planning and selecting and implementing certain practices and certain types of practice, as well as specific plans and specifications that may be associated with these practices. As we'll see in dewatering, there's a lot of different best management practices that are going to be associated with that, and not a one-size-fits-all. So every site's going to be different, every project's going to be different. There's going to be a lot of different practices that need to be taken into account, and this is kind of a good jumping off point to be able to see where you can plan, where you can put these on site, how they be operated and maintained throughout the life of the project. And it's rarely just going to be a one-size-fits-all type thing when looking for solutions and best management practices in general. So Patrick kind of went over some of the details that we're looking in the review process of it. So these are just some of the practice standards that we may be looking at. This is just kind of like a basic template that we're going to be loosely looking at. Just kind of looking at stream diversions, cofferdams, sump pits, and focusing mainly on the practice standard for dewatering, as well as some of the associated ones that are coming down the line for that. So initially, let's say we have a work area that is going to be in or near stream, so we kind of want to focus on how we're going to keep that area dry and be able to divert the stream around. So looking at our practice standard for 976 with a temporary stream diversion. So essentially, it's just a temporary channel or a pipe that's going to be used to convey flow around a project site with the main goals to maintain stream flows, maintain the overall water quality, and provide a dry work area for the project. So the standard essentially is going to take place whenever there's going to be work within a stream or within part of a stream is required. Some things to keep into account. You want to make sure that the flows are going to be low enough or the watershed is small enough in order to be able to divert that either through a pipe, a channel, or a pump. Some things to think about as you're going through, that you don't want to see any significant water level difference, either upstream or downstream of that site. With moving the water, you want to make sure that the velocity of any stream flow is going to be maintained. And then as diversions are being put in place, you want to see those erosion and sediment control devices put in place prior to any diversion construction. So it's important to have those sediment erosion control plans in place before any of those in-stream means and methods are going to be implemented. So Patrick kind of touched on this a little bit before. So there's different types of diversions that you may be looking at. So each standard is going to reference these specific types and then direct you to your standard drawings, which is in section 7, so a different section of the IUM. So you're kind of bouncing back and forth to see what's going to work best for your site-specific conditions. So looking at the conditions on site, the amount of time that the actual practice is going to be planned to be in use, as well as overall flow rates are some of those kind of main things that you're looking at when selecting your type of diversion. Within the standard, there's even more information, more things to consider. So is there going to be flood hazard on the site? Are you going to be able to, will a pipe or a channel be able to convey a 2-year storm event? If pumps are going to be in use, how are they going to be monitored or adjusted throughout the lifeline of the use? So you can see that the reference table here is specifically for diversion channel linings, mainly that they want to have a stable bottom so that there's not going to be any potential for downstream sedimentation. And other associated practices are going to be mentioned throughout the practice standard. So we'll go over a few of them, but coffer dams, dewatering, erosion control blankets, turf reinforcement mats, a lot of this are going to be mentioned and can be referenced throughout the planning process. Some other things within the design, you also want to think about the removal at the end of life. So with, say, if you're implementing the diversion channel, you want to see how you're going to be able to properly fill and stabilize that channel after it's completed. And then just some final considerations that you kind of want to take into account. Obviously, any in-stream work is going to be subject to your local, county, state, or federal regulations. So you want to make sure that you're obtaining and complying with any permits that may be involved with that project. Some other associated practices, so we need to think if you need to get equipment across a stream or across the diversion, you need to be looking into temporary stream crossings. Design and implementation is going to be crucial to minimizing any ecosystem impacts as well. So with any in-stream work, you need to think about if you're clearing stream banks, if you're clearing stream beds, you want to keep that to a minimum if possible in order to reduce the impact to any aquatic organisms within that area. And then this kind of last note you'll see on pretty much all the practice standards within the IUM, that all the plans shall include installation, inspection, maintenance schedules with responsible party identified. So if that gets looked at and addressed ahead of time in the planning process, that's going to save a lot of headache down the road. As you can see, different contractors and different people get involved with the project and figuring out who's going to be responsible for what. So looking down, so we've got our stream diverted, so now we can look a little bit more into those associated practice. So we want to keep our work area dry and away from the stream, so we're looking at a coffer dam. So practice standard 803, so it's essentially just a temporary structure that's used whenever working within a waterway, used to provide a dry work area and contained any of the disturbed sediment within that work area. So essentially, water is going to be intercepted from the upstream area and discharged downstream, either diverted around the whole site or just going to be going through pipe, not through the conveyance. So whichever diversion channel that you chose. With cofferdams, it can allow you to utilize work in areas that otherwise might be unsuitable. So you may see these a lot with shoreline stabilization projects. If you're installing or replacing bridges, culverts, piers, utility installations, really any stream restoration projects, this is likely to be something you'll want to be looking at and implementing. So some of the things I consider would be location. So is it in a large stream? What's the flow situation looking like? If it's in a lake or pond where there's no or low flow compared to a large moving water body, that's going to determine what type of cofferdam and how you're going to be able to implement that. So like Patrick mentioned before, there are a lot of different particular options for cofferdams. So when selecting the type, you want to know your location, your water elevation, and your peak flow levels, just at a minimum to kind of select the best options. Whether you want to go for a full cofferdam versus a partial cofferdam and the specific materials within that. You never want to use any earthen material or any erodible material. That's pretty well stated in the standard right away. So a couple other things to consider as you're deciding that monitoring is extremely crucial. So washout potential can be pretty high with these practices, so you want to make sure that you're monitoring ideally daily and not left unattended for more than 24 hours if possible. And regular inspections are going to be key to kind of the upkeep and maintenance for these practices. Weather is another thing that obviously in any construction site that's going to be important, but especially with storm events, you want to keep an eye on that. And then stabilization should be occurring as soon as it's able to, and then specifically disturbed soils within the coffered area. You want to make sure that you return that to any original conditions as soon as possible. Being able to reseed and stabilize those slopes and restore them back to pre-construction conditions. So we'll touch a little bit more. We've got our coffered area kind of set up, so now we're looking to keep that area dry. We're going to utilize the sump pit. So sump pits, like mentioned before, are just a temporary pit that are constructed to trap and filter water to a pumpable, and pump it out to a suitable discharge area. So we typically are going to see these during the excavation phase of any construction, just to help remove any excess water from the sites and improve quality of the water that's being pumped. So the practice particularly is useful in urban areas during the excavation phase for building foundations, as well as dewatering any designated work areas when in-stream work is needed. So we have here our standard drawing, and then it references a few different material specifications. So those are all located within the Illinois Urban Manual as well, so you can kind of bounce back and forth to see what those would entail. But essentially, the sump pit plan is going to have a perforated vertical standpipe in the center. It's going to allow it to collect the filtered water, usually made of some corrugated metal or PVC. And the pit's going to be filled with coarse aggregate material, and water is going to be pumped from the center out to that suitable discharge area. So we'll talk a lot more about that in the dewatering practice standard. Some of the considerations you want to think of, utilizing the stabilized area. There are additional practices like sediment traps, impoundment structures, or portable sediment tanks. So depending on your site conditions or the size of your site, will typically depend on how you're going to decide where that's going to be directed to. And as well as number and locations of sump pits should be reviewed by a contractor or the reviewing authority in order to see if they need to replace any pits, if they have the correct amount, or if anything becomes plugged with sediment too, we want to make sure that those are being inspected so those can be replaced as needed. So now we're kind of hitting the bulk of what we're going to be talking about is our dewatering practice standard 813. So you'll see this on pretty much any of our review notes and in our practice, our general notes for the district in general, that dewatering is going to follow this standard in the Illinois Urban Manual. What essentially is just controlled removal of water from construction sites, with the main purposes to minimize impacts to the surface water, and minimize any surface water pollution from any suspended soil, to look to help prevent any sediment transport from off-site, as well as preserve any natural resources and property on or off-site, and then provide safe working areas, safe working environment for the project site. So some of the criteria that you want to think about and where this is going to apply. So any on-site or off-site excavated area, if there's a presence of water that may create unsafe work conditions or potential damage to the surrounding area, if there's high water tables, if they're removing stormwater runoff, or if there's in-stream work. But an important thing to note for this standard, this is not for the removal of any polluted water, so chemical, fuel, oil polluted is going to be different. This is only going to address suspended soil in the form of uncontaminated sediment and moving that water. So some of the criteria that we're going to be looking at, so when dewatering on a site, plans and specifications need to be followed in order to remove or divert the water from construction sites and perform that needed work. So the planning and design process is going to be extremely important, especially regarding possibilities for reducing sedimentation and erosion impacts before it happens. So discharging sediment to an upland vegetated area is not going to be a standalone sediment control practice during dewatering, so you need to look at additional options as well. And then once again, your local, state, federal rules and regulations, especially regarding construction of dewatering and disposing of accumulated sediment, need to be reviewed and followed as needed. So some of the criteria and considerations that you want to be looking at, diverting and removing water should include your additional practices, so looking at your cofferdams, channel sumps, diversions, as well as other practices that get implemented, operated, and maintained. You want to keep that up to technical reference standards. So if you're removing water through well point, you also want to look at the number of wells and the intervals needed, and then if monitoring wells may be needed to assess whether pumping effectiveness is required. For our sediment control and removal, it's extremely important that dewatering not negatively affect the quality of the water table, cause erosion, or transport any sediment. So looking at appropriate sediment control practices, the soil type, dewatering method, suitability, as well as the volume of the sediment that's going to be removed, in conjunction with your site-specific location, and then the overall amount of dewatering needs to be factored in when you're designing these practices. Secondary containment practices may be needed, so there could be requirements for sampling and evaluation for any discharge clarity of that water may be included in the process, so that's just another thing to keep in mind as you're going through that. I won't touch too much on this because we'll have a little bit more selection on pumps and filter bags, but just kind of the main points. So when there's low intermittent pump activity, sediment filtration bags attached to pump discharges should be used. So they should be on a stabilized surface and not located in aquatic areas, so in ditches and swales or in the actual water body. Bags should be raised above the supporting ground, so on material that's going to allow flow from the bottom of the bag at its designed discharge rate. And then for the filter bags, you want to make sure that you're looking at the manufacturer specifications. They meet material specifications, specifically for geotextile. And then the recommended size is going to be used based on the size or the capacity of the pump that's being used. So with our plans and specs, at a minimum, we want to make sure that we have proposed locations and methods that are shown on the plan. We have our drawings, specifications, details for any of the items that may be needed in that specific dewatering. Your dewatering plan should be a part of your SWIP and your erosion and sediment control plan with site-specific information. So if there's any total maximum daily load requirements for any receiving waters, or if there's any turbidity standards, those need to be taken into account. And ideally, just having a brief outline with the sequence for the dewatering operations is going to be beneficial and extremely important to kind of see how the process is going to look in planning. So overall operation and maintenance, inspections are going to be critical. So frequency inspections are going to be based on the specific methods that are going to be used, the amounts of discharge, any potential damage to the surrounding areas, and quality of the receiving water bodies. So inspections should be conducted in order to ensure that you got proper operation as well as permit compliance. So properly removing accumulated sediment from the flow area and repairing any diversions as required. So pump outlets should be inspected for erosion, as well as sumps and filter bags need to be inspected for any accumulated sediment to see if those need to be replaced or removed. With bags, it's good practice usually when they're half full of sediment or if the design flow rate is no longer being maintained. And if at any time that you're seeing any signs of erosion, any accumulated sediment, any turbid water, pumping and discharges should stop until you can fully address why that's occurring. So some additional practices that we may be looking at, kind of just go over briefly, but velocity dissipation, especially after the dewatering process, to make sure that any moving water afterwards is going to be slowing down and not causing additional erosion. Polymer use we'll kind of go over because Jonathan will go over that a little bit more in depth. And then any specific other practices that may be in use. So for velocity dissipation and reduction is going to be important for minimizing any of the erosive forces and sediment movement through water flow on and off site. Utilizing ditch checks can be beneficial in helping slow that water movement as well as helping filter any additional sediment that's within the flow path. So some of the main purposes and practices for ditch checks are just going to be reducing velocity for concentrated stormwater flows, help promote settling for any suspended soils behind the check, as well as potentially help promote any infiltration if there's suitable soils present. So obviously with these practices, proper installation and maintenance is going to be extremely important. So I'm sure we've seen some ditch checks that have been just thrown on and can eventually cause more harm than intended good too. So if any additional water clarification may be needed prior to discharge, either in the diversion or downstream, polymers may be an option. Just to note this, that formulations are going to be soil specific. So soil and water samples should be tested with different formulations to ensure that there's going to be effectiveness on the site. As well, just to note that anionic and non-ionic polymers should only be used for stormwater treatment, as the cationic ones can be highly toxic to aquatic life. They're not meant for the stormwater treatment specifically. So there's obviously a lot more additional associated BMPs, so that's why it's probably good to just get an eye on the Illinois Urban Manual and see kind of how it's set up, so you can bounce back and forth between what may be useful at a specific site and what may be complementary to each other or what might not work. So essentially there's abundance of standards that are associated with this dewatering and construction sites, but there's not going to be a one-size-fits-all. So if we were looking at our specific in-stream, using and utilizing a floating silt curtain at the end of it, maybe an additional line of defense to let any of that disturbed sediment settle out and not reach the downstream area, especially as you're looking at removing cofferdam areas. That would be another way to use that and catch and settle out any of the disturbed sediment from the removal process. Another possible option, so if you're working on a site that may be smaller and space is limited, portable sediment tanks may be somewhat of an alternative that can be useful in urban construction with deep excavations. They should really only be used when there's sediment trapping devices that can't be installed. And they're just not as efficient and they can be a little bit more labor intensive, so that's something to consider when you're looking at practices as well. And then any other additional uses, so your sediment traps, silt fences, temporary stream crossings, erosion control blankets, et cetera, may be necessary in developing your plans. So inspecting the operations and the project overall is extremely important while it's active. And then just some overall takeaways. Site-specific conditions really need to be taken into account because that's what's going to choose the best management practices for your specific project. So even if you've implemented a practice a dozen times at a different project, it may not necessarily work the same way at a certain site. So that needs to be taken into account. Throughout the process and life of a practice, things might change and need to adjust. So plans are rarely ever going to go exactly as thought out throughout the whole process. So having backups both on site and planned out ahead of time is extremely important, and that you can kind of switch those out over the course of implementation, seeing what works and what doesn't. As well as having regular inspections for the functionality are going to be crucial and will differ based on several factors. And then always just having additional guidance or second opinion. We've got a wealth of knowledge within this room alone. So being able to reach out about specific plans and being able to utilize the knowledge of others too for specific projects is extremely important. And that is just about all that I have. Once again, we got contact information, and then our general email line is up there as well. That's the current website for the Illinois Urban Manual. If you just type it into Google too, it should pop up. But yeah, if you have any questions or anything, feel free to reach out to the office here. And does anybody have any questions or anything immediately right now? Okay. Not sure who's coming up next, but yeah. So I think I'm next. Yeah.
Okay, we have our last presentation before the break. Right now we have Jonathan, President NCAP. At one point in time, Jonathan was putting these seminars together for the district as the resource conservationist. So let's.
All right, hi everybody, how's it going? Hey, a response, sweet. That's great. My name is Jonathan Kepke. I'm the president and owner of NCAP Incorporated. Prior to coming to NCAP, I was at the Kane DuPage Soil and Water District for 5 years. I see a lot of familiar faces and friends. I was glad to see Mark Bramstead here today. I thought his soil presentation was awesome because I actually learned soils from Mark when I was at the Soil and Water Conservation District. And actually there's a ton of great information in that I'll be able to talk about when I talk about polymer use, dewatering, soils, chemistry, stuff like that. So just as a little bit of a primer, how many of you have heard of polyacrylamides or polymer use for erosion and sediment control purposes? Sweet. How many of you have actually used them? Excellent. Excellent. So this will just be review for you guys, so don't worry about it. So we're going to talk about what are polyacrylamides, what are polymers used for, how do you use them, how do you identify them, select them, do a little demonstration, talk about, go over a few projects where they've been used in the past, show a few unique uses for them that are more passive, especially when it comes to water clarification, not necessarily for dewatering purposes, but you can use these to also enhance your other BMPs. So I'm going to talk a little bit about polymers, polyacrylamides, and what they're used for. So what are polyacrylamides or polymers? Again, long chain, high molecular weight organic compounds. What does organic mean? It's just carbon-based, carbon-hydrogen bonds. So these are, there's tens of thousands of polymers, right? The ones in particular we use for erosion and sediment control, they're more similar to food-grade polymers, which are like your soft-serve ice cream, or thickening agents that are also sometimes added to food additives. But the polyacrylamides that we use for erosion and sediment control purposes are non-toxic, so that is important to realize and talk about. But again, they have, depending upon how you link these monomers together in your long chain copolymers, it depends on what they're able to be used for and what their chemical and physical properties are, right? So in particular, we're talking about polyacrylamides. So these are non-soluble, so they don't form a solution. They're cross-linked, so that means the long monomer chains are cross-linked together. And they have both positive and negative receptors on the overall, on the portions of your polymer chain. But overall, that polyacrylamide or that polymer ends up in essentially three places: cationic, anionic, or non-ionic, right? Anionic, negatively charged throughout the overall polymer. Cationic is positively charged. Non-ionic is non-charged. So that's essentially, all you're talking about is the electrostatic charge of the overall polymer. Only anionic polymers are allowed to be, and non-ionic polymers are allowed to be used for erosion sediment control purposes in stormwater. You can use, there are states, there are areas where you can use cationic polymers, but you must test your discharge water for any remnant cationic polymer before it enters any water course. Why is that? Why do we say we only use anionic polymers in surface waters? Fish kill, yeah, exactly, right? Your fish, your macroinvertebrates, how do they pull oxygen out of water? Gills, right? Anybody would know by chance? The charge of gills? Guess, positive or negative? Negative, right? So if you have cationic polymer in the water course, when that fish is trying to pull oxygen out of the water, it's pulling polymer into its gills, suffocates and kills them. So that's why we say, hey, only use anionic polymers or non-ionic polymers, or again, certain states, certain applications, for example, wastewater treatment uses cationic polymers, but they have to test the water before they discharge it to make sure they don't have free polymer in their discharge water. Okay, well, I just explained that slide. And most of the testing that's required, and most of the manufacturers that make polymers for erosion sediment control or stormwater use, they go through all this testing and they test for acute and chronic toxicity using the water fleet is kind of the standard test, both for acute 24-hour and chronic toxicity for 30 days. Okay, talked about that. So you can use them for land application, you can use them in actual surface water. A lot of different use, and they can be beneficial for cleaning up water. They come in different formulations, right? So you have powdered, which is essentially, don't fly with this. Just almost kind of a sugar consistency to most of it. You have hydrated gel block, which kind of looks like this. This is a little wet for my sample. Comes in logs, looks like soap on a rope. Who knows what soap on a rope is? Am I way old, or is that like, okay, probably a lot of people here camp, so you know kind of what soap on a rope is. And then you also have solutions and emulsions, which you can add to hydroseeders, hydromulchers, to water tanks, for those types of things, and you agitate it, and it basically, mixes into the water, and you can spray it out in that way. So the initial development of polyacrylamides was actually in the agriculture industry. So mostly out west, where they have row and furrow irrigation. And so they were trying to figure out how they could stop the soils from continuing to get suspended and wash out in their irrigation systems. So the USDA Agricultural Resources Service came up with this product that you could spray in your ditches, and it would essentially hold that soil in place as the water flowed over it, and you didn't get that turbidity. So kind of interesting how that came about, and then we've adapted it into the erosion sediment control industry since then. There's a lot of different, this is the NRCS standards from way back in the day. Obviously we have new standards and more updated standards, but this stuff has been researched in a lot of different applications and in a lot of different both university research settings and private research settings over the last really 40 years now, 50 years. In Illinois, we have a standard. It is an awesome standard. It's one of the best standards ever written, right, Dan? Dan and I work together on it, that's why I'm saying that. But so, and this goes through essentially everything you should and need to know, except for who do you buy them from, what are the different manufacturers, all those types of things. But this is a good primer for all that type of stuff. So we're talking about polymer use and specifically in dewatering activities for sediment control purposes. When you're dewatering, if you don't do it right, you can do a lot of damage very quickly. So these are all real sites, real projects that were the result of improper dewatering. So there's like a mile of creek that got killed, and when I say killed, yes, fish killed, everything dead, because they just pumped out of the bottom of the pond. Real impacts to real large water courses because you're not paying attention to what you're doing, and you're silting up the riverbed and causing a lot of damage. So there's a lot of bad things that can happen, but for polymer use in particular, well, I'm going to get to my demonstration in a second, so we'll switch that up. So yeah, there's a couple steps, right? When you're trying to clarify turbid water, first you have to introduce the polymer into your water sample or into your discharge water, right? So you have to get that active polymer into your water. Next, you have to mix it, right? So the polymer has to start to get into the water into a certain concentration where it's starting to react. In other words, it's going to start banging into your suspended sediments that are in the water. And that's going to create these big flock particles. And I'll demonstrate this in a second. But it basically, the whole idea of using polymers and polyacrylamides, especially for discharge water, for water clarification and sediment control, is you take really small things, which are really light and don't fall out of water very readily, stick them together and make them heavy. That's it. Very simple. So have you guys heard of Stokes' Law? Maybe Stokes' Law, right? Material is pulled out of suspension in water by gravity, right? Mark talked about our soil particles, particulate size, right? So I made a little dirty water sample here, and it's been sitting on that desk for about 40 minutes, right? Mostly clay particulates, silts. Now, and this has just been sitting in this water bottle, right? And that's not clearing up very well. Maybe this top little ½ inch. That also goes back to see the heavy particulates are down here? And I can pass this around later. But that's the other thing too, when you talk about floating your intake pump, intake control, right? Your clearest water is always at the top of the water column. And then as you take that down, then there's less sediment for you to have to manage. So that's another great way, if you're gonna have to dewater a pond, that's a great way to do it. But so all these fine particulates are so light that they mostly just, through capillary action, hold up in the water column. So you can let this sit here for you're gonna have to let this sit here for a long time to actually get something that you would consider clean or clear-ish water. So the only way to really solve that problem, you can't filter it, you can't put it through a sock or a bag or whatever else. The only way to truly get that to a visibly clear water discharge is you have to flock it. So you have to take all those small particulates, make them big so they just drop out. And let's see, I lost my clicker, there it is. So here's kind of what it looks like, right? So there's all our soil particles and stuff, you know, and then these long little squiggles here, that's our polymer. So we mix it up, shake it around, have them knock together, and they get really big. And then you just set the water down for a little bit, and they fall out of suspension. And you have clean water. So that's essentially the process. So hopefully this works, or else I'm just going to run out. So I have some flock log that I just kind of got wet because it was old and it's been sitting in my shop for a little bit. And so I'm going to introduce that into our water column. And I'll add a little powdered polymer too. And you see when this stuff gets wet, it kind of gets like, you know when Bill Murray got slimed in Ghostbusters? Like the first Ghostbusters from the 80s? That's kind of what this turns into when it gets wet. I'll add a little powder just, for whats and giggles. And so imagine this water's coming out of your pump, and you put your flocculant in, or your polymer into it, and you just need adequate mixing time. So when you're doing a bench scale test, we talked about testing. You have to kind of do site-specific or bench scale testing on your polyacrylamide. What you're doing is you're taking a soil sample from your project site, and you're taking a few different samples of polyacrylamides, and you're timing it. And you're seeing how long does it take to react. Different polymer formulations will have different reaction times. And so for those of you that are kind of close, you can see it's starting to react. So you see how all that fine, small particulate stuff gets really big and settles out. So obviously it's not perfect, but what you can do, and you can talk about this too, you can get a polishing polymer that you can take and you can sample that too. You can take your relatively clean stuff off the top, and you can have some of that actually get cleaner. So visibly better, not perfect, but if you let this sit for a little bit more. Also too, I didn't bench scale test this. I pulled dirt from a project on my way here. So I was taking a bet, a gamble. But you can see how it is significantly better. And with a little more mixing time and a little more settlement, it'll look much cleaner. But I can pass this around. So the other thing that's nice about this, that chunky material, right? It very easily settles out of suspension, and it'll stay like that for about 30 days. So it's relatively easy to, don't drink it, to capture that. It wasn't as dramatic as I was hoping it was going to be, but that's what I get for not testing it earlier. Dan can probably run it through his test and come up with one that'll clear it up better. Yeah, if I put more polymer in, it could get clearer, or if you mix it a little bit more. But it's probably the polymer formulation that I have. Again, the gel block I use is like 3 years old, so it's also past its shelf life. I could probably drop a little bit more in there, but again, that's why you do your bench scale testing, right? So there's a good example of why, so this is a 70, what was this, what did I say, Dan? 703B? 706B. So this is the polymer that we use primarily around here is by Applied Polymer Systems. They're manufactured in Georgia, right? And they've been in the industry for a long time. But again, so there's a good example why you do a bench scale test, right? So Dan has a couple different formulations in his box over there. If we ran that water through a couple other ones, we would find one that probably would work better. So that works, but it doesn't work as well as we need it to. So again, another good example, do your bench scale test with your soils from your job site, and there's maybe 12, 15-ish that work well in this area. So that's, again, so you want to find the correct PAM formulation and the correct delivery method to give you the most effective flocculation and to give you the clearest water quality coming out of it. So again, that's actually it's probably better it didn't work perfectly. I mean, it worked, but not perfectly, right?
That's why you do the bench scale.
Yeah, that's why you do your bench scale test. Because it'll tell you, and then you'll get it right, and then you look like you look like Mr. Wizard. and not, you know, Mr. Wizard's drunk uncle or something. Go ahead.
Doesn't it sort of basically the same price? So it's not like you go to a site that pops up more expensive.
That's a good question. It kind of depends on the size of the log that you're buying it from the person, the salesperson. So some companies have larger logs. The one that Jonathan was showing there earlier was about the size of a shoebox. And that set of flock logs with the mixing ratio will treat approximately 300,000 gallons of water. Other suppliers will have smaller logs, so you have to adjust, which will adjust your price. But to answer your question, for a pound-to-pound basis, yes, the polymer price should stay the same, whether it's in a gel block form, a liquid form, or a granular form. The other thing that you need to be very, very careful of is us knucklehead salespeople coming around saying, there's only one type of polymer that you need to buy from me. That's a perfect example when some salesperson comes in, says, I only sell one polymer. It
Yeah,
does
not working.
on all soil types.
Yeah.
You go down and use Georgia red clay versus the yellow clays that Mark spoke about up here, completely different.
Yeah.
So those formulations will affect your price as well as your mixing ratio will affect your price. You have to do the bench scale test by law in Illinois to meet the standard.
Yeah, and that's, again, you're talking about the physical and chemical properties of the soil that you're dealing with. So the cation exchange capacity, what the parent materials are, what type of minerals are in the soil, all those things matter when you're talking about trying to select an appropriate polymer. Yeah, that's why I said we use kind of the same 12 to 15-ish formulations in this region for the most part because, you know, I mean, while there is variability, like Dan said, it's not like you're dealing with, you know, Georgia stuff to here to the stuff in the Appalachians. Like, yeah, so we, you know, kind of we know that the bag of tricks that we can work with to make things work here. But those might be a whole different bag if we go somewhere else in a different region. So, but it is a good question and a good point. Go ahead.
Do the polymers have an expiration date, or do they decrease in effectiveness of
I think part of the problem with that one that was like 3 years old is that what they do, especially the gel block, they get dried out. That's why I kind of try to get it wet at first, and it just takes a lot more activation time. So they really don't expire, but they just become less useful or usable, or they are more difficult to use. So, but it's not like, you don't have to like get it right out of the factory and get it at a certain point in time. Anything you're gonna buy from a reputable distributor is gonna be fresh stock, and you're not gonna have to worry about it being so old. You know, I mean, if a guy like me pulls something out of the back of his shop and says, hey, I got a solution for you, don't believe him. Boy, I'm not selling myself here very well, am I? Okay, sorry, I get caught back up. So a lot of these are typically used in just a stormwater treatment ditch. These can be as high-tech, as low-tech as necessary. But the important thing with all these is planning. You have to plan them out, and you have to do your homework ahead of time in order to make sure that it's effective and that it's not either too short, too long, it's overkill, you don't have enough polymer, you don't have enough settling time, you don't have enough mixing time. It's not just something you throw out there and forget it and say, it's magic powder, it's gonna fix all my problems, right? So you have to ensure you have positive drainage in any of your discharge because the water has to actually move. Talked about that mixing time, right? You have to have enough flock logs based on the size of your pump, based on your discharge rates, to have the water actually break off enough of that polymer and then mix into your water column for that chemical reaction to take place. If it's too short or too long, you might be sending all of your flock past your containment system. So, and when you talk about stormwater treatment, you can use pipes, you can use ditches, you can excavate channels, you can use the existing ditch line, you can use just like corrugated pipe we've used in the past. You can make them run back and forth. There's a few, I don't know if they're still around, but there's a couple companies that actually built like some mixing systems that they would bring in on a trailer. Are they still around? They still are, right? Yeah, okay. So there are some local companies that have these systems, they're portable systems that they'll bring out to your job site. And they know what they're doing, they work well, but these can be as high-tech or low-tech as necessary in order to make it work. And then typically, as that water moves down your stormwater treatment ditch or system, you want to have ways to start picking up some of that flock as it moves towards your containment system. The more you can catch heavier up or higher up in your containment system, we call them a dispersion field or that sort of thing, so you can put rocks in there so it mixes the water, but also you can put jute netting on that or other natural fibers that'll start to stick that flock to it. And I'll show you some of the pictures of what that looks like. Typically, when you're flowing your flocculated water towards a receiving water body, you need some kind of containment system. A lot of times we like to use particle curtains, or basically it's just jute netting over some 2x4s or things like that. So as that water gets into like a little small sediment trap or moves through a pool, you have a way to filter out those large flocks and capture them before you get to the discharge point. Here's kind of just a general detailed drawing. You have your introduction of where the flock logs are, the pump discharge. It's going to flow across these riffles to agitate the water. You're going to add jute yarn filter strips here to start to capture your flocks. You built a couple of pits to catch the water, and then you're going to discharge to your receiving water down here. The key of these is that you have to maintain your catchment systems. If you let them overflow, they're just going to blow that water right through. Also, it needs to be relatively still because you need that to follow suspension. If it's flying right through your containment system, you're not going to be able to capture it. Because then once you capture it, you also have to remove it. Here's an example project from a while ago, but this actually was a ball bearing manufacturing company. And I didn't know this, but evidently when you make ball bearings, they send them like really far down into the earth to like cool them, and then they draw them back up. So they had to drill these big, like, I don't know what they were, chasms or something, that they would send the ball bearings down into to cool them and then pull them back up. So they were drilling and they had these deep excavations. Well, in this area they had a lot of clay and flowing sand, and so they were discharging water, but it's in the middle of an industrial park, and all they were trying to do is just put it in a dumpster, kind of lined with some plastic to try to filter it out. But I mean, you'll see the color of the water that they were discharging. You can find the plume at the Fox River. So here's where they're pumping from. We have our introduction of all the polymer system. I think they were going to use 4 5-inch pumps, so they're pumping a lot of water very fast. That's why you see there's so many flock logs, because we need all that surface area to actually get that polymer introduced into the system. So, and then we have our rock checks with some jute on it to start catching the water as it goes by. So that's the color of their water they're discharging. You can see as it keeps the flow down. So this jute netting is also sprinkled with powder polymer. So you can start to see this, all the silt, and it's all that fine clay material that's getting stuck in the jute yarn. And then by the time you get to the bottom, we had a little filtering sump pit here, and then we're discharging as a final discharge this into the storm sewer. So that was what it looked like going in, and that's what it looked like coming out. Here's another one. They were doing a lake excavation. This is one where you actually excavated a channel in an existing future development area. Line it with geotextile fabric, so it's important if you're doing a channel that you have some kind of lining on it and you're not just stirring up the disturbed sediment on the bottom of the channel. You can use plastic, geotextile fabric. We have our rock check dams introduced there. Here's our baffle system that we built with 2x4s. And then these have jute netting thrown over them, so then you can pull the filters out and essentially replace them. The nice thing about using coconut fiber or jute fiber is that it's very hairy, and that tends to stick to those flocculants really well. And so it'll just stick to it. Where it looks like there's a bunch of void spaces in it, it actually will, we'll get a better look at it up here. So you get to the point, see how open the pore space is? By the time it's cleared up, or by the time this is filled up, you can't even see through it. There's so much silt and flocculant attached to it. The nice thing about that too, of using this biodegradable material, is you can just dig a hole and bury it. There's no disposal. You just find a non-structural area, dig a hole, because it's all organic. It all breaks down. So you can just bury it right there. You don't have to dispose of it in a landfill. Obviously, the geotextile fabric has to. And so here's the example of the water clarification. That's what it looked like going in. That's at the first settlement area, and then that's the discharge. Head wall construction, this is a little bit of a different application. So what we did here is just use the existing ditch line. It was an open ditch on the side of the road. They had to replace that head wall. That's the water they're pumping into the system on our flock logs. And then you can see we just used the ditch line. We lined it with geotextile fabric, put the jute netting over it, added a few sandbags to make the water kind of skip back and forth. And then by the time you're getting down near the end of the jute netting, it's nice and clean. And then you can just continue. We used a triangular silt dike as a little catchment area. And again, very simple, very low technology, but incredibly effective. You don't have to build the Taj Mahal on these things. They can be pretty rudimentary, but that's my boot. Can't even see my foot, how much flock we actually caught in this little sediment trap. And the nice part is it's right next to the road. They could just come in, scoop it out, take the material off. Just a little more detail on that, but again, relatively simple. We use the existing features to make it cost effective as well. You can also use pump bags or filter bags. As a word of caution, these will clog very quickly if you're using polymers. So you're going to be swapping them out all the time. And if you don't, it will explode. Been there. I saw it wasn't me doing it, but I saw it happen and it was like, whoa. And then again, it's kind of showing how the jute netting captures that the flock in it, how it kind of sticks together. And then you can also use polyacrylamides to combine with other BMPs, right? So I showed that ditch line, and one of the unique applications that we can actually do is create your ditch, take rock ditch checks or other ditch checks, put that jute netting over it, and then sprinkle it with a little bit of polymer. If you know that it works on that job site with your subsoils. They did some research in some DOT sites in North Carolina through NC State. A colleague of mine, Rich McLaughlin, who's recently retired, but that's actually, he used to run a polyacrylamide training center at NC State. And I actually went out there for a 3-day weekend, and he had a whole course on polyacrylamides and how to use them and stuff like that. That was when the technology was pretty new. That would have been early 2000s. But it was really useful, but also, so his research, all they're doing is they're taking straw logs and a little bit of Excelsior blanket, and they're spreading polymer on it. Sprinkle the polymer on, so if there's dirty water, turbid water, so this is obviously in North Carolina, they got those red clays, they get that turbidity, they get those spikes in turbidity, even in semi-vegetated ditch lines or that sort of thing. So they compared this to rock check dams, right? So they're trying to say, well, what's gonna be better, because they got trout streams up there and stuff like that, for keeping the turbidity levels down, especially during spawning season. And so this is it was a very simple experiment. They just set it and forget it, and then go out there and test during rain events. But they came up with, these are in NTU units, nephelometric turbidity units. Anybody ever use an NTU meter before? Yeah, I know some. Yeah. So an NTU meter is a measure of the turbidity of the water, right? Basically how clear it is to see through it. They're portable, they have to be calibrated, but you can take them out on your job site and use them if you need to say what NTU standards. At one point in time, IEPA was actually, or not IEPA, US EPA was actually going to regulate an NTU standard. Anybody remember that? Remember they put out the NTU guidelines years ago? Oh man, that was a disaster. But anyway, so here's the example. Their standard was rock check dams. Their fiber-only dams was their other control, and all they had to do was sprinkle on a little bit of PAM powder to get them there. So we've actually used this in a couple of sites. They actually made a standard for it for North Carolina DOT. We did a passive system on a project, so they had these rock check dams. They were worried about the color of the water coming through here, and they just had a lot of fine clays that were open in this ditch line. And it actually worked really well. So a little bit of vegetation, but you can see what the turbidity is above and below those rock checks. So again, is it perfect? No. Is it a significant improvement? Absolutely. And this was, we just went out and we would visually inspect and say, okay, does it look like that netting is full? Okay, recharge it. So, you just go out, sprinkle a little powder on between rain events or every week or every other week, and you got a system that can be really effective there to knock your turbidity down. So, general things, plan ahead. Select your appropriate polymer. Make sure you have someone that knows what they're doing. If you don't have someone, ask around. There's lots of people that know how to do this stuff, right? Utilize your existing drainage systems if at all possible. Be creative, but also make sure you have a capture and clean out mechanism, especially if you know that you're going to have a lot of sediment that you're going to have to deal with. Make sure you have an appropriate size containment unit, because again, you don't want to just be blowing that out into the river, which has been done before, because they didn't have an appropriate size containment unit. But actually, you could go out and you could put your foot on the bottom, and you can see the flock stir up and fall right out. It's not good because you got to go back and recapture it, but it was still active, right? So you could go after that, but that's what they had to do. They had to go out and they had to scoop it out and filter it out and pull it back out of the river bottom. So, any other questions? I kind of went through a lot there. Go ahead.
What's the max ratio of sediment to polymer that would typically
Rephrase question, please. I'm sorry. I got lost.
per mass of polymer, what mass of sediment?
Oh, you're going to capture way more. Okay, I got you now. By both weight and volume, you're going to capture much more sediment than you will by weight and volume of polymer. So it takes much less polymer to capture a larger weight in sediment and flock particulates. Is that the question you're asking? Yeah, no, it's like an exponential ratio, because those long chain polymers are super, super tiny, right? But then you'll see in the jug I floor, you see how big those flocks get, right? So, and it just keeps binding and binding and binding to whatever it can capture onto. So you get a lot more sediment removal by weight and volume of sediment than you do by polymer. So, but now that I understand your question, yes. Sure.
You said there's 12 to 15 types of polymers for this area and soils in this area?
Yeah.
Is there a big cost range in that 12?
No, not huge. No, it really more is like Dan said, kind of the formulation, the size of the logs, the weight of the logs, the weight of the polymer. Most of the polymer, in and of itself, by its own weight, it doesn't fluctuate that much, 5% difference in cost, but it's pretty equivalent. It's not like one's going to be $1 million and the other's going to be $100. Yeah. I would say, unfortunately for that, I would say no. Just because a lot of times, even your soils information that you have, depending upon what you're digging into or the spot you're digging up, I prefer to go out and just say, okay, where is it happening, and then just take a grab sample. Okay, here's your kind of mid soil, here's your subsoil. Let's mix them together, because that's what's going to happen when you're digging or excavating or trying to do this. Because this is during a construction project, you got to get the water clean. So then you can kind of test 3 of those soil samples against the 10 or 12 and be like, okay, this one looks good for this, that looks good for that. And then you kind of got your recipe or arsenal picked out to know what to use. Yeah. It's not that much. Yeah, it's really much more of a, especially when you're pumping, it deals with a lot more of the volume of your pump water and your discharge. That's going to be your number one ratio. Your other ratio for cost of implementing these systems, how dirty your water is, because that's going to dictate how often you have to clean the jute out, how often you have to clean the trap out, how much labor, how much machine time is it going to take. The dirtier the water, the more expensive it's going to be. The more water you pump, the faster you pump, the more expensive it's going to be. So, but that's kind of general rules of thumb. Again, you can say, okay, one flock log treats 300,000 gallons of water. What's my gallons per minute? How many pumps am I running? How many logs do I need though? Because I have to have enough surface area to get enough polymer into the water to actually get it to mix and to get the chemical reaction, right? So, but those are the things, those are the kind of the steps of the decision making. But you can get relatively decent estimates together without having to like do it in an emergency because we got to do it right now. Yeah. No problem. Go ahead.
That's what I was gonna ask you, as far as like the design of this, is this something that as a contractor you're typically doing, like you're not getting
Yeah, I haven't put a design together for one of these that I haven't built myself. No one's called me to say, hey, will you design one for me? But you could.
is this coming out of the permit process, like by the pool,
It's usually coming, yeah,
thou shalt use, polymer?
permit process, extra sensitivity to the receiving waters, a contractor that's gotten themselves in trouble before, and has a little non-compliance history or something like that. So it's more on a case-by-case basis that has said, hey, you guys are going to need to plan for this, or you guys are going to need to do this. And then they're calling us or whatever to come up and be ready with a deployable system should they need it. But most of the time it's like, hey, we're going to need it, set it up, and let's use it.
Is there a cutoff as far as like the length of the dewatering operations where it's like it's not cost effective, like you gotta just like, you're gonna be out working, you're doing this culvert replacement project, you're gonna be out there for 3 weeks or 3 months, and then this is
The longer you're gonna pump, the more cost effective it's gonna be. Most of the time, it also depends, it's how dirty is the water that you have to treat, because again, it comes down to you have to comply with the rule. I don't care if you're pumping for 3 days, but if that water's gonna be bad, you're gonna have to do something. You can't just be like, well, it was only 3 days, I don't know.
you'd be surprised by how many people say
Oh, I'm talking about, the contractors could say that, but the regulators, I don't think the people doing the inspections or your regulatory people are gonna be saying, don't worry about it, it's just a couple days of really dirty water. It'll all sort itself out. Go, do you have a question? Yeah, no, that's exactly what, Dan has a little kit there that has a bunch of samples in it, but that's exactly what we do. Come out to the job site, a watch, some different samples, start stirring it, take notes, and do it right there in the field. And then as soon as I leave here, I know who I can call Dan and be like, hey, okay, I need this, this, and this. Okay, here's your pricing. I think I need this much of it. And then I can tell the contractor, hey, here's what we got to do.
Just to clarify, do they sell sample kits so that you have a little bit so you can do your own scale testing, or do you have to buy?
Usually you got to buy larger samples, or do you?
Give away sample kits. Once again, based on the permit, if you do a bench scale test, you need to be a PE or a CPAS. So if you need one, contact me, we'll send you one out. It has like small little samples of the smaller logs that are typically look something like this. And then that way you can go ahead and do your sample test.
No, you're fine. I was just going to show, this is kind of Dan's little cheat kit. So it has you see different colors and different labels. So like this is from a gel block standpoint, this is the handful that he'll take out there and run through. And then he's also got the powdered, and then from there, once you kind of get a family together of like, because most of the time when you're dewatering, you use the powder in conjunction with the gel block. Just one or the other typically isn't effective. And then that's where we talked about like the polishing or the final clarification, right? That's where that picking the right powder to clarify at the end gets you the whole package. But typically, then you'll have kind of a tag team of what's your gel block that's needed, and then what's your powder that's needed to give you the most effective result.
Is there a list of what soil type work best with polymers
Not that I'm aware of. Yeah, I don't have a cheat sheet for you. Oh, yeah.
What you expect for the area you're in.
Right.
Large classification.
No, I mean, you could go to like Applied Polymer Systems and contact them directly and see, but they'll probably just refer you to Dan. They'll be like, oh, you're in Northern Illinois. Just go talk to Dan. Go ahead. Yeah, go ahead. No, you gotta apply it yourself. Yeah, I mean, it's really easy. You just like, you know, take your bag and then you put it in a cup and you just kind of shake it out. No, no, no. Visual estimation and confirmation, something like that. And if it's not, and as it starts running, it's not going to run clear like immediately. It's like, okay, that might be a little bit of a first flush. Then you're like, okay, tweak this. I needed another log, or move that, or let's agitate it a little bit more, or let's add some netting here. So you kind of have to have somebody that knows how to tweak the system. You know, it's not just like a turn it on and walk away kind of thing. Yeah. So those big, and that's where I said it like, when it feels like slime. So, like, and you can kind of look in the bottom of that glass and it looks slimy down there. Like when the guys are pulling that netting out, I mean, it's like, it looks like snot, like you got hit by a slimer. But that's a lot of what it does. It sticks to all those fine hairs, creates that, you know, sticky kind of jelly consistency, and then you can move it around. Go ahead. Good question. Colder the water, the longer reaction time. So if it's so temperature, in colder temperatures, it takes longer to react. So that is a great question. So in the summer, it may react faster than it would be in the winter. But great question. Thanks for bringing that up. Other questions? Most of it's like between 45 seconds to a minute. And we used to kind of use general rules of thumb too. Like in a mixing swale, unless it's like really rushing, typically you need about 100 feet of mixing time. So like there are some kind of rules of thumb that we've learned from experience, but it's not going to be the case in every single situation. But typically it's, you know, 45 seconds to a minute is a pretty good reaction time. Other questions? All right. Oh, sure. Go ahead.
What do we know about the impact of the liquid effluent?
Yeah, we don't know that much about it. That's just the reality of the situation. I mean, there haven't been visible fish kills when it's been used. I mean, but there is no, there hasn't been. I mean, other than them putting the polymer in with the water flea, like that's the only. There hasn't been any long, detailed studies on that through extended use. Good to see you again, Steve, by the way. It's been a while. Go ahead.
After you bury it, how long does it take to finally
Just the same. I mean, whenever the jute netting breaks down, yeah, the polymer typically is active for about 30 days, but then after that, it just kind of goes back to the earth. I mean, nothing ever really goes back to the earth, but I don't know. I haven't done one up to see. Any other questions?
You have to collect samples. Do you have to test those samples, or is it just a visual?
Just visual. It's a visual test. Visual clarity. That's what you're looking for. And because that's really essentially what our water quality standard is in all of our erosion sediment control stuff is, does the water look clean or does the water look dirty? All right. If there's no other questions, I hope this was educational and informative. I blew way over my time, so sorry for cutting into your break, but grab me at break or whatever if you have other questions. But thank you. Appreciate it.
Okay, the time is now 10:20. We're going to take a little bit of a detour. We're going to, before the show, we asked if you could submit your good and your bad dewatering photos. So we got a couple, and we have a couple prizes for the winners. So the good, the bad, and the ugly. Okay. So this is kind of the photo that you've seen before. out in the field, we see the guy jumping on the bag. We didn't address that during the Illinois Urban Manual presentation, but that is not a recommended practice from the Illinois Urban Manual. So for our first submission, we have the good photos. And we have kind of what we see, another treatment train right there. Looks nice. It's got the perimeter control surrounding the train. Nicely sized bag. And we have a nice clean outfall. So the winner of the good photo is James Chambers. Thank you for the submit, James. And then next, which I tend to have a much larger quantity of bad photos than good photos, but we got some bad photos. We got a little bit of sediment laden water leaving the site. And the winner for this one is Art Polowitowicz. Art? And here's some more ugly photos. We didn't sync this all that well. But so next we'll move on to Patrick Verhalen with the Army Corps of Engineers. He's going to talk a little bit about the regulatory frameworks and what's kind of applicable for our presentation here.
Morning, everyone. For those of you that don't know me, I'm Patrick Verhalen. I'm one of the, I will say, newer regulatory project managers at the Corps, the Chicago district. I've been there maybe 18 months tomorrow. But today, Patrick had asked me to talk a little bit about in-stream work plans. I know that's been a hot topic among the transportation community over the last couple of years. So I'll do a little overview of the nationwide permit program, how it relates to in-stream work plans, and talk about, I have a couple examples of what we look for when we review them. Chicago District readopted all the nationwides in our footprint. For those of you that don't know, we also picked up an additional 4 counties last year, Iroquois, Grundy, Kankakee, and Kendall. So those are now within our regulatory boundaries. Biggest difference between, so we have 2 different types of permits for nationwides. We have non-reporting and reporting. Non-notification or non-reporting nationwides are ones that have very minimal impact. There isn't much that needs to be done. You have a small impact in a wetland. A good example is ComEd replacing a single telephone pole or a power pole in a wetland. Yes, there's 32 square feet of impact, but they are saying that they're not going to have any prolonged impact. There's not going to have any sedimentation issues. This would be something that would be a non-reporting permit, one that we don't necessarily need to review. Also within the nationwides, there is a threshold. If you have some sort of impact up to about a half an acre, anything usually over a half an acre will be an individual permit or a letter of permission. Whether you report or not, you still have to follow the general conditions of the nationwide permit program, and erosion and sediment control is in there in condition number 12. So a lot of times you'll hear us say PCN. It used to be pre-construction notification in terms of talking to some of the different agencies, agency coordination. Now, what you submit to us is considered a pre-construction notification. You're telling us that you have a project, it's going to have some sort of impact. There's 58 different nationwide permits that we review, or categories. The PCN, or pre-construction notification, will be required for any projects that impact over 1/10 of an acre of the waters of the U.S. Most impacts of an aquatic resource other than a waterway, so wetlands, fens, and some permits do not require us to be notified at all. That doesn't mean you don't need to follow the rules. Just because you're not reporting it to us doesn't mean you don't need to prepare some sort of notification. What we typically recommend is putting the joint application together and some of the supporting documents and having it on site. That way, if someone does question, hey, why are you replacing this culvert with the same what it was, then you have some sort of documentation rather than us getting a blind phone call saying, hey, they're screwing around in the water, you need to find them, which really isn't what we do. If you want to come in and you're not sure which way to go, whether it's a pre-construction notification or non-pre-construction notification, you can call us, set up a pre-application meeting, but we can't not confirm with you that your project is non-notifying, because then that still requires us to go through the process of reviewing the actual project and the merits of that project. Like I mentioned earlier, erosion and sediment controls are required under general condition number 12. We do still maintain our agreements with the SWCDs and the Lake County Stormwater Management Commission to perform oversight. A lot of times if you apply for a permit from us, one of the conditions will be that the SWCD or SMC actually reviews your erosion control plan first before we authorize your project, and that they maintain weekly inspections to ensure permit compliance. Other thing to note, if you have a project, and I guess this is more for applicants, if you have a project and you're worried about contractors that may not always follow the rules, it's still a good idea then to submit and require or request a permit from us, even if you meet the non-reporting conditions. And we say that because we cannot add special conditions to a non-reporting project. So if you have a project and you want us to say they need to review, you want us to review your in-stream work plan, we can't say that that's required under the non-reporting conditions. This is something that I know we've been working with the Tollway and IDOT for in some of their smaller projects is it meets the non-reporting conditions, but they still want the contractor to provide an in-stream work plan. We can't require that, but IDOT can through their special provisions, if they really want that in there. If you have a project and you see there's erosion control issues, don't hesitate to call us and we'll come out or call the SWCDs. Let them know that, hey, it looks like there's an issue. If it's something that they think we need to be involved in, then they can bring us in and we can move forward there. When we submit, or when we review a permit, we have 7 standard conditions that we include in our permit authorizations for in-stream work. And I put them, the full text in the application or the PowerPoint here, and we'll go through each of them, and then I'll go through a couple more things and we'll show how they actually apply. So number 1 is work in the waterway should be timed to take place during low or non-flow conditions. We want as little water going through your site as possible because then that reduces the amount of potential sediment impact downstream. Plan must be designed to allow for the conveyance of the 2-year peak flow. So most storms, we want your BMPs to handle a typical storm event. I know that's hard to say now because it seems like we get these 50 and 100-year events quite often. But we want you to be cognizant of what may happen while the project is under construction. We don't need the full hydraulic report when you submit your application. IDOT's putting in a waterway table to show what the 1, 2, and 5-year storm events are so that we have an idea of flow, and that the contractor does as well. Water should be isolated from in-stream work area using cofferdam of some non-erodible materials. This is a big one for us that we definitely look for. There's another condition that I'll talk about in a minute that requires us to review the plans. But we want to see something that's not going to be easily removed by a water event or is going to cause sedimentation. Sandbags are good if they're wrapped in geotextile fabric. A lot of times sandbags alone at a higher flow can still carry sand downstream if they break. Steel plates, inflatable bags, and A-frame cofferdams are good examples, depending on what your situation is. Number 4, cofferdam must be constructed in the upland area and no equipment in flowing water. Not every contractor has perfectly clean equipment. Usually there's grease, dirt, oil, hydraulic fluid, whatever on it. We don't want that material getting in the water. So whether the contractor's placing the equipment by hand or placing the cofferdam by hand or by utilizing equipment needs to be put together or assembled on dry land before it's placed in the water. Bypass pumping is necessary. Intake hose should be placed on a stable surface or floated. Jonathan talked a little bit about that before. You don't want to pull all the sediment off the bottom and then have to treat that. Filtering of bypass water is not necessary. This is something I'll show in one of the examples I have of an in-stream work plan where just because you're bypassing your site doesn't mean it needs to be treated. We want to make sure that your discharge isn't causing erosion downstream, but if you're taking clean water and passing it around your site, it still should be clean on the other side. So don't try and plan on forcing an 8-inch pump or a 10-inch pump through a filter bag, because that's just not going to work. Number 6, during dewatering of the coffered area, all sediment water must be filtered. So once you have your work area isolated, then you need to have a dewatering system in place. A smaller pump, something to remove the water on a daily basis, and then this water, your discharge, needs to be filtered before it's discharged out of your site. So this is where we'll look at the water upstream of your project. If it's clean, that's your benchmark. What you discharge should be just as visibly clean. Number 7, portion of the side slope that is above the observed water elevation shall be stabilized prior to accepting flows. So any of your discharge needs to be on something stabilized. Riprap into a filter bag on riprap or some other stone stabilizer. We don't want you pouring water out onto grass, causing more erosion of the bank. So those are the 7 that are pretty much in every project that we have in-stream work. Another one that I always put in my projects, because I want to verify that the contractor or the applicant is following a condition, is prior to commencement of work, you'll submit your plan for your cofferdam and in-stream work, and you can't start that work until we review it and okay. We just want to have something in place where if someone complains about water quality downstream, we have something defensible. We can say, this is their plan. We can give it to Patrick or SMC and say, hey, this was their plan. It's not functioning. Can you help them adjust it? Some of the things that we require or look for in an in-stream work plan is a narrative that's complete. It tells what they're doing, how they're doing it, what kind of staging is required. If you're doing a box culvert in 2 or 3 different stages, we want to know what those stages are, and that you've anticipated closing up one stage before moving to the other so that you're not causing issues with your work. What kind of monitoring is going to happen? Are you going to check it every day? Are you going to make sure that the water is continually clear through your system? Are you going to check to make sure your flock levels are okay? Are your filter bags clean? What kind of time frame are you going to be reviewing that to make sure that you're still complying with discharging clean water? What kind of contingency plan do you have? If the bag breaks, what are you going to do? We're going to stop the pump and replace the bag, clean up whatever discharge. Also, we want some sort of either drawing, shop drawing, a sketch, or an engineered plan that shows what your sequence of events is going to be. We've had some take your structure sheet, put a dot, this is where our pump is going to be, we're going to put our hose this way, this is where our cofferdam is going to be with our flume pipe through the box. Something that illustrates us, when we go out there, yeah, it looks like that's what they're doing, that's what their intent is. And lastly, continuity between the 2 documents. What you're showing on your plan should meet what is in your narrative. I've had several where they're not the same. One of them is an example. So I have 2 examples here. One of them is from the consultant, one of them is from a contractor, and I want to preface to say that I'm not comparing a consultant designing an in-stream work plan to a contractor, because the first one that I got from the contractor isn't that great. So I don't want to say that contractors don't know how to put a plan together. It was just riddled with errors. So this project was in Indiana for a bridge replacement project. All right, so you can see at the top, they've shown where their cofferdam is going. They're using sandbags on both sides of their work area for the replacing the abutments and the embankment. They're showing, this is their approximate location of their pipe. This is where they're putting their filter bag. And then that aligns with what they're showing here. So there's intake hose, it's not on the bottom of the ground. There's your pump discharging into a filter bag onto some stable velocity dissipator, either stone, pavement, or sandbags. So they're not specifying what exactly is in place, but they're still meeting the requirements of it's a filter bag on a stabilized surface, making the contractor decide what's going to be used. And on the right down here, you can see they're showing where they're putting their sandbags, their sump pit, their discharge tubing, and where they're putting their filter bag. In the text, I know it's small, but also their text went along with what they were showing. Here was a contractor's in-stream work plan, still a basic sketch. They're showing they're putting their pump up and across the site over the roadway and discharging it on the outside of their cofferdam, so that's their bypass. Here they were trying to say they were going to put it in a silt bag, but they were also specifying an 8-inch pump at 3,500 gallons per minute. Now, Dan, you can tell me if they actually make a bag that'll handle that. But if your water's clean before it gets to your site, then there should be no reason to filter it, as long as you're dissipating the velocity coming out of your hose. They also marked up the urban manual detail and mentioned using a 2-inch pump for bypass. So there's your inconsistency, because in the text in here it said an 8-inch pump. So we want to make sure that what you're saying you're going to do and what you're showing you're going to do match. Other minor issues I had on this is the stream was actually flowing from the top of the page, so from north to south. So really they're just flooding their site if this is how they're going to work it. What else? So if you're someone that's reviewing the plans, make sure that what's happening out there really matches what's in the plans, what they're saying they're going to do is what's shown. Ultimately, this plan was revised. They fixed everything we needed to, and it was an acceptable plan. It worked pretty well. And I believe that's everything I had. So, if you have any questions on in-stream work plans or the nationwide permits, I'd be happy to answer them at this time. Sweet. If you come up with something later, feel free to hit me up after the presentation.
Okay, next we got Dan Selsinger. I don't know. We can try it out. It might be an on-off. Whoa.
Yeah, that's good. Thank you, Patrick. Happy New Year, everybody. Good morning. And thanks for taking the time with us today. There was a question on polymers. If somebody wanted a list on, I think, basic erosion and sediment control polymers, were you asking for that? So if you send me an email, I can give you like a little bit of a cheat sheet for different types of polymer flavors for erosion control and sediment control. Once again, everybody in the room, at least the seasoned veterans, understand the difference or the definition between erosion control and sediment control. Okay? So same thing applies with polymer. The flavor of the polymer that you're going to select is based on whether you're doing erosion control or sediment control. The bench scale test that I perform, I need to know up front, is it a sediment control bench scale test or is it an erosion control bench scale test? Very, very important, okay? So I could put that list together. And then I think this gentleman was asking about pricing, correct? So a lot of times, what we do with a lot of your peers is we'll have a means and methods pay item. Once again, we want to pay the contractor. We know what the goal is, pay the contractor to do the work, okay? So put in the means and methods pay item, and then all the consumables, you can split out and have them as pay items. Flock logs, dry powdered polymer, jute yarn, pumps, whatever you want to add in there. That's typically how we go ahead and address that. And then there's a percentage of the total value of the contract, then you can allocate for dewatering, okay? Or erosion or sediment control, whatever you're looking at. Does that answer your question?
Yeah,
Okay.
just for the dewatering, we don't always know what the contractor's plan's gonna be, but they need to estimate what their flocculant's gonna be, their costs, and it's, right now, a lot of the times it's incidental, to the overall contract cost.
Absolutely, and I'm always pushing my designers, in a good stormwater pollution prevention plan should have a dewatering plan in it, at least a basic starting point, okay? That way then you can at least figure out what those costs are, and the contractor knows what the responsibilities are on site. And if you want to work offline on some of that stuff, I can help you, but I've worked with IDOT and the tollway. I'm trying to tighten it up a little bit. And it's easy enough to do, but once again, you need to tell the contractor what we want. Design it, it's just like we're talking about dewatering, okay? I have contractors that know dewatering like the back of their hand, and they do an excellent job. I have other contractors on the other side that fail miserably, okay? I have the same thing happen with my designers. I have really good designers that give me a phased stormwater pollution prevention plan, which is what they should be doing, and they've incorporated a dewatering plan, okay? I'm gonna pull a slide up here in a minute. What's clean water? What's clean water? What's the permit? Is there any, hang on. Is there anybody new here today? Who's new in the industry? Anyone? Oh, we got a couple over here. There's a couple of hands over here. I'm just asking because I'm not going to put you on the spot. I'm not going to ask you for the answer. That means everybody else in the room's fair game. All right. So, what was the question?
The answer?
The answer?
Clean Water Act is fishable and swimmable.
Fishable and swimmable. What about maximum extent practical? Yeah. MEP's in the contract, is in the permit, right? I'm gonna pull a slide up. How can I select a tool out of the toolbox for dewatering if I don't know how clean the water needs to be? Do I need a mechanical method, or do I need a chemical method that Jonathan was just talking about?
It's gonna be as clean as what the water was originally. You mean, if it depends on your source.
Yep.
So
Yep.
it can't come out in a different color than it's already there, so, and that's how you.
Excellent. So you're using a background limit, right? They were using a background limit, which some people do. We can't send water off our job site to a location dirtier than the water that's receiving it. Or some people will use the water that's coming to them, okay? Or at one point up in Lake County, we had 50 NTUs as our water clarity. Can I get to 50 NTUs with a mechanical method? No way. Can I get to 500? Yeah. And I'm going to show you a couple of pictures of that. But once again, as we go through the dewatering presentation here, and I've got some overlap on my slides with a lot of the other speakers, and that's great because we're all singing from the same hymnal, right? We're all talking the same language, so I'm going to kind of just breeze over a couple of those, but it's good that we have good continuity. And it's good that we have new people coming into the industry that want to come here today and learn. So, once again, I'm going to pull a slide up, but I want you to keep in mind, while I'm talking here and everybody else that's talking, what's clean water? If you're an inspector on the job site, a regulatory person, somebody at the Army Corps of Engineers, what is clean water? If I get pulled into a dewatering meeting and I don't know what the goal is, we're wasting our time meeting. Okay? Same thing from the designer's standpoint. If I'm going to push the designer to have a dewatering plan, if the regulatory agency hasn't told the designer what the rules are, we're going to have a problem. Okay? So, once again, what is clean water as we go through this? In the meantime, I'm going to pass around 2 different types of fabrics. I just wanted to make it around the room because I'm going to get to a point where I'm going to talk about geotextile fabrics and which type of fabric works well setting up a filter cake or a filter bridge when you're filtering out sediment or flock from a dewatering operation. Okay? So Mark taught us about soils, and remember which soil is really, really sticky? Silt, sand, or clay? Clay, right? And what do we normally do with a lot of these geotextile fabrics? We blind them off. What's happening? That sticky clay is sticking to the fabric. Okay? So just look at these 2 different types of fabrics. One's a woven monofilament, looks like a window screen, round yarn. The other one's a non-woven needle punch, it's a soft felt. Okay, just feel them, pass them around, and look at them. So, when we're dewatering, what's the ultimate goal? We want to get back to work as fast as possible. Either the contractor is there working, and he needs to dewater the area to finish his work, or actually do the goal of why we're at the site, or possibly we had a large rain event and we're trying to dewater the site to get back to work. That's what we're dewatering for, right? So we want to get back to work as fast as possible, and we want to protect the environment to the maximum extent practical. Swimmable, usable, as Steve said. Okay? That's what we're looking at as designers, and we're also looking at as contractors. The other thing is a lot of times when we get a stormwater pollution prevention plan, once again, I'm not throwing stones at the designer because they might not necessarily know how the contractor is going to build the job, but once again, has the contractor relayed how he's going to build the job. Take out your crayons and fix your stormwater pollution prevention plan or your dewatering plan. We talked about that earlier. You can certainly do that. It's a living document. It's meant to be adjusted. But let's give everybody on the team a place to start. Whether we're having a pre-construction meeting, whether we're having a pre-erosion and sediment control meeting, maybe it was in the design phase when we were sitting down with the owner. What is clean water? What is our dewatering plan? Different types of dewatering. Patrick asked me to talk about bags and the sump pits, which I will. But these are all other types of dewatering that we see on a site. Set traps and set basins, or we may need to dewater the set trap and the set basin. Skimmers, ditch checks. We have contractors or owners on a site that will dewater the site and let the water go down into the channel or swale and use the ditch check as their sediment control device. We're using bypass pumping that we talked about. Diversions. What? We saw a bunch of slides already on diversions. Why are diversions so important on a job site? If that water gets on our job site, what happens? We got to deal with it, exactly. No wrong answer, just yell it out. We're all learning. Once again, we let that clean water get on the job site, we now got to clean it. So divert clean water whenever possible. That's what I tell people to do. Silt fence. A lot of times people, whether it's silt fence or a roll perimeter, everybody's going to dump the water out to the outside perimeter and think that the silt fence is going to be the magic gun, the magic bullet that's going to clean the water. Well, if we're putting it through a dewatering bag and we just spent time, effort doing that, why are we now running the water out of the bag towards the silt fence. I'll show you a couple of pro tips on how you can adjust that. Jonathan kind of led into a little bit of that with polymers. Same thing with inlet protection. I treat inlets as the perimeter of the site. Most cases, we don't always know where the water goes, okay? So once again, inlet protection, we're not going to want to overwhelm it with a lot of dewatering, and a majority of the inlet protection devices can only handle so much flow. You send a 2-year, 24-hour rain event to an inlet protection device, you're going to overwhelm it. However, the EPA tells us that's what we got to design to, right? Polymer mixing tanks, that's not a settling tank. That's not a Baker tank. That's not a rain for rent tank. Okay? Polymer mixing tanks. Understand the tools in the toolbox. If you don't, bring somebody up alongside of you that understands the tools in the toolbox. Those are two different things, polymer mixing tanks and settling tanks. Now, one of the changes to the NPDES permit about dewatering, anybody know what that is here recently?
Daily reports.
Daily reports. Your dewatering, you now have to inspect your dewatering every day. Who's changed that? Designers, you have that in all of your stormwater pollution prevention plans? Contractors, inspectors, regulatory people, how are we going to address that? We need to inspect every single day the dewatering operation. What are we looking for? So we already alluded to some of those maintenance items, and I'll talk about that in a minute. 5, 50, and 500 NTUs, okay? So once again, the measuring stick is what on the job site? What is our goal for dewatering? This gentleman shared with us that we're going to use a background limit or where we're discharging to. Excellent idea, okay? Maybe we have a regulatory agency putting an NTU limit on us. In order to get over here to the, what's drinking water? How many NTUs is drinking water? 5 to 7? Okay, Jonathan alluded to this, is the federal EPA had some NTU limits originally. We were at 7, then we went up to 280. Then all the Bass Unlimited, Ducks Unlimited, Sierra Club, everybody was up in arms. Then the contractors got upset, the Home Builders Association got upset. And right now, here we sit with maximum extent practical. What's clean water? I can't select a tool out of the toolbox until we figure that out, okay? Now, there's a difference between improving the discharge water or demucking, all right? If you're going to go in and you're going to take your suction hose and you're going to throw it on the bottom of the said trap, said basin, whatever you're dewatering, a hole, and you're going to pump the sediment out, and it looks like chocolate milk, that's a demucking operation. That's not a water clarification. That's not the proper term to be using for dewatering. Okay? So understand what we're trying to do. That's why the Illinois Urban Manual is telling us to put in a sump pit, because we want to lower our point loads. We don't want to overwhelm whatever type of sediment control practices we have in place to clean the water. Okay? So once again, what's clean water? Am I really actually cleaning the water, or am I demucking? Big difference when we're out there on the job site. We saw the Illinois Urban Manual practice already over here on the far left, far right, to the 7 minimum requirements. Patrick just outlined those for an in-stream work plan. The only thing that I'm going to add to it is probably 90% of the time, I see the person that develops the in-stream work plan is the person sitting in the office, and the person that's out in the field, the dirt boss, he's trying to implement it, and those two people are not on the same page. Happens all the time, okay? So if you're the person, either as a designer, crafting the in-stream work plan and the dewatering plan, put some thought to it. How do you think the contractor's gonna build the project? If you're not sure, ask a contractor for some feedback. Ask some of your peers for some feedback. Same thing with the contractors. The person in the office developing the plan, talk to your dirt boss. Hey, is this how we're gonna build the job? How many times do we go to a stormwater pollution prevention plan, dirt boss says, I'm moving the dirt from this side of the room over to that side of the room. But my stormwater pollution prevention plan's got me going from this side of the room over to that side of the room with the dirt. Is that plan any good anymore? That's why we do phased stormwater pollution prevention plans. That's just erosion and sediment control 101. Okay? So once again, what we're looking for is communication between the two, the person that's implementing the plan and the person that actually developed the plan. I think that's kind of what Patrick was talking about also. And we see it on job sites all the time. Sump pits. The sump pit standard that we had up before with Tommy was a 94 version. There's a brand new version ready to be released that will upgrade that sump pit. So stay tuned. You want to use, where's the clearinghouse for all the feedback for the Illinois Urban Manual standards? Right here at the Army Corps. So stay tuned, keep an eye out. If you want to comment on the standard, the technical committee will be releasing that pretty soon. There's a lot of changes to the sump pit coming, all right, that standard. It's been crafted already. It's just a matter of getting it released. So it'll be coming soon. But when we build a sump pit, we can float the intake. Once again, what's the goal? We want to what? Lower our point loads, okay? Lower our point loads. So we can float it if we'd like, or we can actually construct a pit. We want to make the pit big enough so that maybe we could add some polymer in. You can see a log sitting in there. We can jump start the polymer mixing. If we want to shift from a mechanical method to a chemical method, you typically will put the pipe in, as Tommy shared with us, and then there's usually a gravel pack that's put around it. Now, if you look at the new standard, they're going to tell you to put wire mesh around the pipe, then a geotextile fabric, then the gravel pack, two different gradations of gravel pack. One is more of an armoring stone, the other one's a smaller stone. The smaller stone is so you can easily maintain the gravel pack, okay? Why do we put mesh around the pipe, metal mesh or plastic mesh? Why is that around that perforated pipe? Keep it from blinding. Yep, the geotextile fabric. So the selection of the fabric's important. Why do I tell people never ever use a sock on a perforated pipe? It's the worst thing you can do. What happens when you backfill that pipe with a sock on it with gravel? Where does that fabric go? Where's that sock go? In the holes. You lose half of your flow like that fast. That's why you want to line with a fabric, put stone in, put your perforated pipe with no sock, more stone, then more gravel, overlap the fabric. Same thing applies here. That's why the new standard has the wire mesh around there. Same thing if you're building a standpipe. Same exact thing, okay? The fabric flavor that they're going to want, there's only one fabric that's going to be allowed around this pipe now. It's going to be table 1. So you're going section 592 that Tommy taught us. Section 592, that's all your fabrics. You have 8 flavors of fabric to pick from. Table 1's wovens. Table 2 is nonwovens. Table 1, class 4, that's the monofilament fabric. I'm passing that around. That's the fabric that looks like a window screen, okay? I'll tell you here in a minute why that one works better than the soft felt nonwoven needle punch. The same practices that I'm going to tell you why it works good for the standpipe or sump pit in this case applies to a dewatering bag also, okay? We're trying to set up a filter cake or a filter bridge. Here's another thing that I think is great. I like these pumps. I don't sell them, but I think they're called warthogs. Here they are. It's a warthog. So it has the suction built into the bottom of the pump. The pump you just push out on top of the water column. Jonathan was talking about decanting the clean water off the top of the water column. That's what this pump does. There is no suction hose. So as the water goes down, the pump rolls down. These pumps can run dry without actually burning them out. What a great idea. I think they work awesome. Dewatering bags. What's the minimum size in Illinois? 10 by 15. Can't use a bag smaller than that for a 10 by 15 bag is the smallest bag that you're allowed for dewatering in Illinois. 4-inch diameter or a 4-inch pump is the largest pump that's allowed to go into a bag in Illinois. Where am I getting this information? Urban Manual. Okay, Tommy showed you where to go. That's where I'm going. I'm just reading through the standard and it tells us right in there. What are we supposed to do if we have a pump larger than a 4-inch pump? Anybody? What are we supposed to do? Go ahead, Joel. Great, 2-inch hoses. So you could go ahead and manifold. What Julie's saying is go ahead and manifold it off. So we'll bring in possibly, in this particular example, 4-inch, split it into 2 tubes if we had a smaller bag, okay? So it's a manifold system. Contractors are very resourceful. They understand and know how to get it done, okay? All you got to do, if you're the designer, I'm going to end up using a manifold system. I want to use an 8-inch pump, but we're only allowed to use this size bag on the job. Use a manifold. What else is allowed? Said traps, said basins, mixing tanks, mixing swales. Those are all other tools in the toolbox that the designer and the contractor and the owner of the site can use to accomplish the goal. Okay? So we have a lot of things at our disposal. It's just together we need to work at a team to go ahead and figure out which one's best. And then we need to provide, as everybody has told us before, a stable route for the water to travel back. If we're going to spend time, effort, and money to clean the water, well then get it off the job site. What's the goal of dewatering? Get back to work as fast as possible. Or dewater so we can finish the task on site at that time. That's why we're there, okay? If you wanted to use, instead of visqueen in this particular case, or a liner, you can go in there to the Illinois Urban Manual, the fabric flavor that you want to use. It's going to look like a silt fence fabric, okay? Silt fence fabric barely lets any water go through it. It's because it has a flat yarn. That's table 1, class 1. That's the fabric you want to use if you want to put it underneath your dewatering bag and provide a stabilized route as the bag leaves. Tommy talked about elevating the bag. What do I typically like to use? Pallets and FODs. These are stabilized construction entrance mats. They're 12 foot by 7 foot, but these little pyramids will elevate the bag high enough so we get credit for the surface area below the bag, along with the surface area above the bag. Same thing with the pallet up on the upper left. You can use rock if you'd like to. I just like these two because they're reusable. The other reason why I like them, let's say I want to have a stepped approach. Whenever I do a dewatering plan, I do a stepped approach. I may start with a sed trap or a sed basin, or a bag and a sed trap and a sed basin. Maybe I need to add polymer. Whenever I do my dewatering plan, I start at the very basic low end to control cost, and then I tell Patrick when I submit the plan, I'm going to step it up as I inspect my dewatering system every day now, every day. Okay? So that affords me to what? Blow dry powdered polymer. I'll take a backpack blower, or I can take a McDonald's cup of dry powdered polymer, put it on one end of the bag, and wash it underneath the bag. That goes back to what Jonathan was talking about, to further polish the water clarity if needed, okay? If needed. That's why if we do secondary containment around the bag, don't put it right against the bag. Move it back away from there so you got a little wiggle room to work. Same thing if I'm going to take my dewatering bag, do I want to run it right to the limits of my project? You better make sure that that water's crystal clear coming out of that bag, because you don't have much room to treat it further if you need to, okay? This is all part of putting it into the plan. One hose per bag, or do we add a manifold? Julie already taught us this, okay? We don't sneak into two hoses, just get a manifold, get some PVC pipe, build a manifold, put 2 bags out there. Not that big of a deal, okay? What's happening to this bag? Why do I see this going on that geotextile fabric right there? That's blinding of the fabric, okay? This is the soft felt fabric, which is the most popular. So that sample, when it makes it around to you, is that soft felt fabric. If you hold it up to the lights, it has dark areas and it has light areas. That's called random opening sizes. Those fabrics are very susceptible to clogging and blinding. Who's had, any of my PEs and structural folks here had formal training in fabrics? Not a one. So we as an industry do a horrible job of training people on how to use geotextile fabrics. I sell over 400 different flavors of fabrics and grids. How do I go into my box and select the proper tool? Or do we just keep going? I want that black shiny stuff, I want that black soft stuff, right? Or give me that window screen stuff, okay? But like for example, the window screen, we can sew it more open, or we can sew it a lot tighter, the opening size on the window screen stuff. And that's all based on filtration. We're trying to hold the soil particles, the clay that's sticking to the fabric. The silts and sands, we know are bigger particle sizes than the fine colloidal clay. They're going to drop out of suspension quickly. Okay? So those soft felt bags will only really work if you've got really sandy soils, because Mark taught us that it's going to drop out of suspension quickly, like Jonathan said, based on Stokes' law. Anything else? We need to flocculate it. The fine colloidal clay will go right through the bag. Okay? So understand your soils. That's why Mark's talking today. Understand the soils that we're working with to help you develop your stormwater pollution prevention plan and your dewatering plan. So, blinding. Blinding is when the soil particles will blind off the top portion of the fabric. You also see this when you used to be able to put a piece of fabric underneath the grate in a street. Sediment would run to it. It gets on top of the fabric. It blinds it off. It's sticking right on the top. Then what do? We come through and we poke holes in them, right? Clogging is when the soil particles get into that soft felt It's like a maze and they can't get back out. There's a distinct difference between how the fabric is reacting. Is it blinding or is it clogging? This also happens with underdrains all the time. Bioswales, rain gardens. Why are they failing at an alarming rate? Because we have bad plans or contractors that are swapping products out and construction managers that don't even know what they're looking at. Bring somebody up alongside of you that understands what the products are or become educated on them, okay? We don't want the bag to get to this point so that we have a rupture. This is blinding and clogging. We needed to flocculate the sediment here, or we need to change the geotextile fabric. Right here is the blinding and the clogging. Blinding on the surface, clogging is inside the fibers. The window screen fabric up here at the top, it has a consistent opening size. So when that fabric goes into service, soil particles will go through it, big particles line up, then medium-sized particles line up behind that, and fine particles line up behind that. Mother Nature does that naturally, correct? If you're ever digging a trench sometimes, look on the side of the trench. She'll set up her natural filter cake, filter bridge. That's what we say in the industry, filter cake, filter bridge. That's what we're trying to artificially set up right up here. Big, medium, fine particle sizes. So when that fabric goes into service, it'll burp some sediment out, but then all of a sudden, as soon as the fabric sets up its filter cake or filter bridge, the water will run clean. The opening size of that fabric, that window screen, is based on the soil particles that you're working with. That's why the conversation that we had with Mark earlier is important. So we understand the soils. We already know that we need to discharge. We talked about this with Tommy. Wherever we're discharging, we want to stabilize it. I already talked to you about secondary containment. It says in the standard that you could put secondary containment around there to further treat the water that's coming out of there. I wouldn't go that tight to there with those bags and then in that particular application. Here's some examples where somebody's taken the time and effort to run water through a dewatering bag, but then what do? They sent it out across exposed soil and we just wasted time, effort, and money. Same thing if we're going to overwhelm an inlet protection device. Some of the things that you can do is that you can window your silt fence. Has anybody windowed silt fence with that window screen fabric? Perfect idea, right? Well, we're not allowed to send more than a half acre of drainage to 100 feet of barrier. Erosion Control 101 in design, right? No more than a half acre. So what do I do if I've got more than a half acre? Well, I'm going to put some windows in. I'm going to grab some monofilament fabric, I'm going to put that in the silt fence, and I'm going to window it so the fence doesn't fall over. Okay? Here also is another pro tip. You can take some straw or wood chips, take some of that dry powdered polymer that Jonathan showed you, and if you had a misstep like I showed in the picture before, where the water's getting dirty again, you want to polish it, just take the dry powdered polymer with the McDonald's cup, and just sprinkle it in with the straw or the wood chips. And you'll be surprised. It's not magic, it's a chemical reaction that's happening, okay? All of this has to be designed. That's why we need the designers on the job site to provide us our stormwater pollution prevention plan. And we as contractors and industry suppliers, we got to carry it out, okay, and help them along. We don't want to put it next to the receiving waters, we already know that, and up alongside a wetland or anything like that. We do not want to use a stand of vegetation as our sole erosion and sediment control device, okay? It says that in the standard. A stand of vegetation is not allowed to be used. We do not put dewatering bags on any slopes. Why? They'll roll over. It's not a trick question. It's just common sense, a lot of the stuff. Don't be afraid of it. Maintenance. We're now inspecting our sites daily.
as of now. It just changed in the permit. Intake, we're inspecting the sump. Is it in good condition? Is it working? Do we have debris around it or not? Is the discharge color good? Where do we find our discharge location on the plans and specs? Is it listed in there? Should it be listed in there? Designers? Yeah. Contractors, do you know it's in there? Inspectors, do you know it's in there? That's where we're checking clean water, okay? It tells us right there, where's the discharge location? That's where I want you to go and sample. It's just like when I see people, are you drinking this, Patrick? No. Okay. I didn't want to get it all goobered up, but you see people that walk out there and yeah, I'll see this all the time. The inspector will walk by. Yeah, that's dirty water. You just walked by and you told me that's dirty water? That could be the sediment in the bottom of the pond that's already sitting there reflecting back up. Take a clear cup, test tube, whatever it is, and take a grab sample. Then hold it up. Okay? Compare it to that other picture. What is our clean water goal on site? Have we met it? Okay? Anybody that's just doing a drive-by and says, yeah, I got dirty water right there, it's just like testing silt fence. Okay? If you're an inspector testing silt fence, you're supposed to get out and you're supposed to pull it out of the anchor trench. Can you or can you not? So let's all work together as a team. Once again, what's clean water? What is our sampling requirements? Let's get all this out on the table. Some of this stuff stings a little bit to talk about, but let's get it out there right away at the pre-construction erosion and sediment control meeting. Okay? We're not trying to trip each other up. Let's just communicate. Replace the bag. Is the discharge good? Replace the bag. Stable router for the flow. Is it still good? Our discharge point, is it stable? Winter conditions. Somebody with winter conditions you were talking about before, right, on polymer? So we just went through a little bit of a cold snap. I had a couple of dewatering operations going on. What do you do to protect your dewatering operation in cold weather like we just went through? Suggestions? No one's dewatering during the cold weather? Heat tracer tape works great. Concrete curing blankets over top of the system works great. Maybe you got to blow a little heat in there. So if you have winter operations going on and we're worried about the polymer freezing or the whole system freezing, there are means and methods. Ask your contractor. Once again, they're very resourceful. They'll figure it out. They know what they're doing. Some contractors are better than others, but they'll help you through the system. And then the secondary containment. Do you need secondary containment or not? Do you need to improve your dewatering plan? Okay, remember I told you, always use a stepped approach. And that's a baffle system there is what that picture is that you're looking at. Questions for dewatering? Bags, pumps, fabrics? Sir? Question is, can I explain what the manifold is? So when we have a pump larger than 4 inches that we want to put into a dewatering bag, the quickest and easiest way to do that is to take some PVC pipe with a bunch of elbows on it or Ys on it, and then break that flow up into multiple discharge hoses into 3 or 4 additional bags. So we stay underneath the 4-inch threshold is what we're doing. You can also manipulate or change the manifold to inject polymer. Once again, a stepped approach if we need to. Where else could we put some polymer if we want to do a chemical treatment? In the sump pit. Questions? Okay, I'll be around afterwards if anybody else wants to talk offline. Julie?
I know a few years ago, I'm thinking of like bentonite used for directional drilling. There wasn't really a polymer to block out bentonite. Has any progress been made in that?
Yeah,
Polymer used now?
that's a great question. So the question is, going back to the polymer, is there a flocculant that works with drilling mud? The bentonite is basically the facilitator. It's going to be the lubricant. But in the drilling muds that are out there, you have to be very, very careful of what proprietary blend is. And I can say that because I'm a sales rep, okay? As soon as a supplier says proprietary blend and you're using a drilling mud, you want to find out, if you're overseeing the project, what is that proprietary blend. Most of the bentonite type drilling muds, and a drilling mud will protect the drilling head if anybody isn't sure what that is. So if they're boring, they want to protect the head, and that's what that drilling mud does. You want to make sure that it does not have cationic polymers in it. I can probably tell you, and correct me if I'm wrong, Julie, because I know you did some research on this, but I'm going to say probably 98% of the drilling muds that are in the industry have cationic polymers in them. They don't tell us that. They say it's a proprietary blend, or it has a surfactant in it, okay? The federal EPA says if you have any cationic polymers on your project, you can use them. But what do you have to do? All the discharge water has to go through a sand filtering device, and you have to test the water, like Jonathan said, before you return it to the receiving waters of the U.S. That's what the federal EPA tells us. We all have to be as restrictive as the federal EPA. IEPA here does not allow cationic polymers. So the best way to deal with what Julie's talking about, the drilling mud, most of the drilling mud manufacturers have a flocculant that works with their proprietary blend of their drilling mud. You want to ask for the contractor to use that flocculant on site. And if I was the owner of the site, I would ask for a letter that the sales rep selling it, the company, takes full responsibility for any massive fish kills. Put it in my SWIP book. That's what I would do if I'm using drilling mud. Now, there was a drilling mud standard that we worked on. I don't think it was released. Kane, DuPage, and Rick McCandless at North Cook Soil and Water Conservation District, they did craft a drilling mud standard, but it never ever got released. Once again, because there just isn't enough information out there about which drilling muds are safe and which ones are not. But at least 96, 97% of them have cationic polymers in them, okay? So all you got to do is ask for their flocculant. Use their flocculant, flock out the water, test the water before you discharge it. You probably want to run it through a sand filtering device, return it back into the environment. Does that kind of help? You cannot put, I'll add this, and you know this because we talked about it. You cannot use what Jonathan was talking about. You cannot put an anionic polymer in the same area as a cationic polymer. The two of them will fight. You have to go in and break the chain with acid. Who is going to go out on a job site with acid? Not going to happen. Okay? Not good for the environment. So that's why you cannot use, or any of us salespeople trying to tell you use an anionic polymer with a drilling mud, I would be very, very careful. Okay? Because it's not going to react. you could just simply tell them, show me that in the bench scale test. Show me simply that it will react with it. Same thing if you got a drilling mud. I've had drilling mud guys come to me and say, oh yeah, you can flock it. You can use an anionic polymer to flock it. I've never been successful doing that, ever. Okay? So, once again, protect your company. Make sure you get a letter from the supplier. Have the supplier back it up. How many times do all the designers out here do I tell you, put my name and number down there and make me go out there and inspect the installation of X? I'll do that. That's my responsibility. I want to make sure it's working out there. Tell that drilling mud that drilling mud sales guy, that manufacturer, the same thing. Put it in writing that you're going to take responsibility for a massive fish kill. That's safe for the environment. Illinois EPA requires LC50 testing for any polymers used on a job site. Jonathan talked about that. What is LC50? Lethal concentration, 50% water, 50% polymer, and then the water vertebrae has to live. You want to use anionic polymers on a job site? Your SWIP book better have LC50 testing in it for all the polymers that are on there. Why are we not getting the same thing from the drilling mud, folks? And it has to be tested third party. It can't come from an in-house test. That's just like MSDS sheets. We type up the MSDS sheets. Yeah, it's important if it's flammable, but once again, be careful of what you're reading on an MSDS sheet for polymer versus an LC50 test. Okay? If you guys still got questions, Julie, ask me later. Any other questions? Okay, thank you for your time. Patrick?
Okay, next, since we all got you in the room, we're going to take a second to take a little break from dewatering discussion and talk about our cost share program, which we will have cost share available this upcoming year, and our coworker Isa is going to discuss that. Let's see.
Good morning. My name is Isabella Borzica, and I've been working as the resource assistant at the Kane DuPage Soil and Water Conservation District for about 3.5 months now. We're going, as we transition from talking about more technical stuff to general stuff, I want to give a brief presentation about the urban cost share program that we offer. Now, this program is called the Partners for Conservation, or PFC program. This is offered by the USDA, and the Soil and Water Conservation Districts help to offer this program to landowners. The purpose of this program is to help conserve soil and water resources, as well as improve soil health and pollinator habitat, which is done by addressing the concerns related to soil erosion and water quality. A water well decommissioning project, or WDP, is also offered, and the purpose of this is to decommission water wells to reduce the potential for groundwater pollution. Special projects are also offered to address unique resource concerns that may not be addressed by traditional conservation practices. Each conservation practice is identified by a code that comes from the NRCS Field Office Technical Guide, or FOTG, that can be found on NRCS's website. And each conservation practice also must be maintained for a minimum number of maintenance years, which may vary depending on the practice. However, on average, it's about 10 to 15 years. Now, this program is open to any landowner in Kane or DuPage counties. Now, private entities are prioritized for funding, and public entities may qualify for funding only after all eligible private sector requests have been approved. Now, how this program works is that each practice is eligible for up to 75% of the estimated state scenario cost, or a lower percentage if the total cost of implementation happens to be greater than the established state scenario cost. Now, an example of the latter would apply to conservation cover project that consists of the use of a monarch species mix, which has a state scenario cost of $980.47 for 1 acre. Now, this would produce a 75% cost share rate of approximately $735. Now, if the total cost of implementation for an acre project by a landowner is about $1,200, then the $735 in cost share for the state scenario would produce a 61% cost share rate. Now, the first conservation practice I will be discussing is conservation cover, emphasizing the pollinator habitat. The purpose of this project is to enhance wildlife, pollinator, and beneficial organisms while focusing on the higher quality nectar and pollen species. This practice must be maintained for a minimum of 5 years. This practice helps to address erosion and water quality while attracting target pollinators, particularly the monarch species. Next is critical area planting. This must be maintained for a minimum of 10 years. This establishes permanent vegetation cover on a site that is void of vegetation, either due to a natural occurrence or a newly constructed conservation practice. Now, this practice helps to reduce erosion and off-site damages while also stabilizing the site using the lime, seed, and fertilizer. The grade stabilization structure must be maintained for a minimum of 15 maintenance years. This is installed in natural or constructed channels that require a structure to stabilize the grade. This helps to reduce erosion and improves water quality. And some of the structures that are include the treated wood structure, which is shown on the left here, as well as precast concrete blocks, shown on the right, as well as rock riprap chutes. But for this conservation practice, I would say there are between 12 to 15 different structures that are applicable to it. Next is the rain garden, which must be maintained for 3 maintenance years. I believe this is the lowest numbers of maintenance years for a conservation practice in this program. These are installed in depression areas that allow rainwater to run off from impervious urban areas such as roofs, parking lots, and driveways that are then absorbed into the ground. This not only helps to reduce rain runoff, but also minimizes the risk of erosion, flooding, water pollution, and diminished groundwater. The last practice that may apply to an urban area includes water and sediment control basin, focusing on the narrow base. Now, this must be maintained for 10 maintenance years. However, there is also a temporary scenario that may be applied in the case of a construction project, and that would be installed for the duration of the project, which may vary, but on average is about a year. Now, these are constructed along the slope of a minor drainage way, along an earthen embankment, or a combination ridge and channel to form a sediment trap and water basin to help reduce on-site and downstream runoff while trapping sediment and reducing the risk of rill and gully erosion. Another program that's offered is the Stream Bank Stabilization and Restoration Program, SSRP, which addresses the concerns related to stream banks. As you may know from what you've seen, stream bank erosion occurs when soil and rock wears away from stream banks, and the purpose of the SSRP program is to demonstrate effective and hard-armored stabilization techniques along the stream bank toe. The funding for this program provides cost share assistance to landowners that may have severely eroding stream banks. Now, the funding for this is a separate funding source and is subject to funds becoming available only once they are released by the IDOA. Before the Projects must be signed off by a professional engineer and must be ready to construct once the funding window becomes available. If you are interested in applying, the Kane DuPage Soil and Water Conservation District will be able to help you out. You can either call us or send us an email using the contact information shown above with any questions you may have or if you are interested in applying for the program. On our website is an application that you can use to fill out for the PFC program, and we will work with you from the time you fill out this application to the implementation of this project and beyond to help you learn more about what conservation practice or practices you might be interested in implementing and help you throughout the application process to determine if you may be eligible for funding. Now, additional information for this can be found online. If you want to learn more about the PFC program, you may go to the Illinois Department of Natural Resources website and go to their conservation tab, as well as the SSRP program. There is a designated section in the Illinois Department of Agriculture website. At this time, I will be taking any questions you may have about this presentation. None? Okay. Thank you.
Okay, and we are accepting applications for that cost share program up until April 15th. That's our general period to be taking in applications. Next, we have Kat with our office, who's going to talk a little bit more about RSWCD and SWCDs in general, just if you're not familiar at this point.
Clicker, or do I need to stay here? Okay, cool. Which way am I going? Up? Up to move forward, okay. And to move, okay. Awesome, okay, so I'm batting cleanup today. My name is Kat. I am the administrative coordinator at KDSWCD. I try answering the phone with our name. It's kind of an interesting bunch of letters that we have to put together. This is our team. You've heard from everybody here today, including Mark. Mark is also here. He was not present for the picture at the time. He was digging somewhere in the soil, I'm sure. But let's take a look at, hello? This one? There we go. Okay, I'm going to take you back on a little bit of history here. This picture may be familiar to some people if you think back to middle school history class. This is the 1930s, and it is the Dust Bowl. So we had prairie land out in the Midwest United States. We took those prairies out and we put in cropland. When that cropland failed because of a drought, we ended up with soil that was exposed to the elements, baking in the sun, and when the wind came along, this happened. And it went from Oklahoma all the way out to the eastern seaboard. Washington, D.C., in their infinite wisdom, said perhaps this shouldn't be happening. So they just put together some things with the USDA that today we know as the NRCS, which is a partner that I think you may have spoken about earlier that we do cost shares with. We also work with the IDOA that Isa was telling you about with doing some cost share programs there. So what ended up happening with conservation districts? We were also initiated at this time when these events were happening. Here in the state of Illinois in 1961, we adopted the Soil and Water Conservation Act, which put into place exactly how the 98 SWCDs in our state are going to be organized. And this is a locally organized and operated unit of government functioning under state law to promote the protection, maintenance, improvement, and wise use of soil, water, and related resources within the district. So this is our mission. These are our walking papers. This is what we're supposed to be working on. So we're mandated, but we're not funded, which makes for an interesting business plan. What do we do? So we do things like we do this. We do education and outreach. We're out in the schools. I did a presentation on watersheds for an Aurora 8th grade recently. Mark and I went out to the DuPage County, DuPage COD, College of DuPage, there we go. So we do things out in the field. We help to have people understand what it is that we do, not unlike what we're doing here today. We also do some watershed planning. Tyler Creek and Jelkes Creek watershed plans, we facilitated those. We just put out a grant request for a 604B so that we can update the Jelkes watershed plan. We do technical assistance. CRP programs, IDOA and NRCS programs where we can put conservation cost share practices in place. We do both the technical assistance and try and find you funds to do these things. And then there's the things that we partner with here today. Sustainable urban development. How does this happen? These are partnerships that we're trying to foster and grow throughout the counties. Kane and DuPage, we happen to cover two, that are very different counties. We also cover both agriculture and the urban side, so we have a diverse number of things that we need to be working on. Memorandum of Understanding is one of these partnerships that we want to put into place. We are seeking additional municipalities that we can partner with. What do we want to do with that? We're going to take a look at your engineering plan reviews, and we're going to help be your boots on the ground out in the community. Talk to us. We have an opportunity that we can partner with you. We also do things like engage our future stewards of the land. This is Envirothon. Every year, SWCs sponsor this program. It is a competition. Teams of 5 high school students will compete on 5 topics: soil, water, wildlife, forestry, and then there's a wild card topic that changes from year to year. This year, it's renewable energy for a sustainable future. These kids will compete on a local level. They will then move on. The winners will move on to state, and the state will move on to nationals. Last year, Lincolnshire, Stevenson High School, moved on to nationals. They placed 15th. So the winners there will get scholarship money. So there's skin in the game here, but as anybody who knows who's put on a shindig like this, it requires a lot of resources. So what we would like to ask you today is if your organization would like to be a sponsor, we would gladly accept whatever might be comfortable for you. I have information for this out on the table out front. Some other things that we do to try and make ourselves some money. We put on different kinds of events. One of them coming up is our water testing event. We do well water testing. Tests available in our office. We gather the water all on a single day, and then we take it back to the lab on behalf of the landowners, and the reports are sent back to the landowners directly. We also have a plant sale. Plants, native plants, trees, and shrubs that's coming up this spring. We also sell fish. Is there anyone from Roselle here? Roselle Park District just contacted me. They want to order their fish from us this year. Again, this will be a repeat order for them. So these are some other ways that we have avenues for making money. We also do a poster contest that is with the National Association of Conservation Districts. So it's a nationwide contest. We also have a photo contest, which hopefully we'll get some more pictures than we got for our little photo contest today. Then I want to bring you back to that Soil and Water Conservation Act. This act not only tells us what our mission is, but it tells us how we're supposed to staff the office to get this done. It says that we need to have a staff, and it also dictates that we have a board of directors. These are elected officials. There's 5 of them. On odd years, there's 2 of them up for election, and on even years, there's 3 up for election. This is an even year. It's also a leap year. It's also a cicada year, which is going to be interesting. It's a double cicada year. So we have voting. February 8th is our election. We have 6 candidates for 3 positions right now. If you're interested, the slate for those candidates is up on our website. I would encourage you, it's a privilege to be able to vote. Soil and water is important to everyone in this room. Please participate. If you cannot make the February 8th, we do have absentee voting, which is going on right now. Come out to our office and you can vote up until February 6th. And that's it. We're done for the day. It was a wonderful morning. I want to thank everybody for coming out. We've got a great turnout here today. Thank you for everything that you do out in the field. You will have noticed that Jesus is up there doing a video that is going to be available on our YouTube channel. I will have certificates for your continuing education credits. They'll be emailed to the address that you registered with. The speakers will also be providing me with their deck, and the decks will be included in that as well. Questions, thoughts? Anybody want to shout out anything? Okay. Thank you for everything that you do out in the field, and thank you for being here today.